Hello everyone, welcome to GATE ESE's GTQ 2022 Gate Through Questions. Myself Haneef, and I'm here to discuss control system. With this brief introduction, let's proceed to discuss the subject. There's no time for the introduction, there is no need as well. And in this session, maybe it may last for maybe 2-3 hours at the maximum. We will focus mainly on the questions. No theory will be discussed because you have already gone through. And if you are GATE ESE student, of course you studied the complete control system with me. There's no need to reiterate or revise the theory again. We will be revising that through questions. So we are going, just before 1 week of the GATE examination that you are hardly left with, I would like to focus on some enthusiast questions, some important questions that will recall all those contents that you studied with me in control systems, maybe offline, maybe online, whatever be the thing. But you will be able to recall all those contents that you studied through these questions. And I'll be focusing on the simplest way of solving questions rather than trying to elaborate them. See, we don't have 10 minutes of time or 5 minutes of time or 15 minutes of the time to solve a question. We are not in the mains examination of engineering services where we have got 20 marks weightage and 20 minutes of the time. No, we have to be very quick and smart and at the same time accurate as well. So you need to hardly finish the question in a minute or at the maximum couple of minutes. If you're taking more time for that, to solve a question more than a couple of minutes, except very few, maybe hardly 10% of the questions of the entire paper. In control system, you will have say maybe around 6 to 7 questions or maybe 8 questions in the entire paper. So maybe one question may be taking time beyond 2 minutes. That's very rare thing. Otherwise, most of the questions can be finished in a minute or even less than that. Some of the questions, if you are conceptual, if you know the concepts to the extent, then you will be able to answer to them directly. So it's a very scoring subject and very time saving. Control system has got two features to help you out. It is a scoring subject and also time saving. It will save a lot of time for you to solve these 8 questions. I don't think that you need more than 8 minutes of the time or hardly 10 minutes. So hardly any other subject has this kind of facility to you. So control system mostly numerical, and of course to some questions will be theory as well. So without wasting much time, let me be straight into the subject. As far as the introduction of control system is concerned, you need to focus on the classification of control system and their merits and demerits. If it is open loop, what will be its performance? If it is closed loop, what is performance? Because these questions will be covered for the theory questions jaise aayenge, and I gave you around 6 to 7 points of open loop and closed loop, wherein you can discriminate between them, that how does an open loop system performs, its merits, demerits, a closed loop system performs, its merits and demerits. Focus on that. And in a closed loop, how does a negative feedback system behaves and a positive feedback system behaves. One of the biggest myths that students have regarding feedback, that too particularly negative feedback, that it increases stability. But you will be stunned to see that in spite of applying negative feedback, certain closed loop system, they become unstable. You will be stunned if you have this mind. I told you many times, I used to warn this, that no feedback ever promises stability or instability or marginal stability. As part of introduction, one important thing that I would like to highlight, because you may again mess up with that in the questions. Negative feedback system may be stable, unstable, marginally stable. Positive feedback system may be stable, unstable, marginally stable. Individually, any system can be stable or unstable or marginally stable irrespective of the feedback it has. Open loop system may be stable, unstable, marginally stable. Closed loop system may be stable, unstable, marginally stable. Doesn't matter which feedback you have applied. Then, sir, what is actually the concept? A negative feedback system, a negative feedback closed loop system is always more stable compared to that of positive feedback closed loop system, where the basic system is the same. Means in a system, if I apply negative feedback, I will get more stability than applying positive feedback in the same system. That's the right concept. That way. So never study halfway. Half knowledge is more dangerous. Right. So never think that negative feedback increases stability. No, you say it completely. Negative feedback increases stability compared to its counterpart, which is positive feedback. Your complete control system is relative. It's not absolute. There is no absolute statement. It's all comparative, relative statement. PD controller does not guarantee stability. It guarantees more stability than PI controller. Lead compensator does not guarantee stability. It guarantees more stability than lag compensator. Minimum phase system is not guaranteed to be stable. It is more stable compared to non-minimum phase system. Negative feedback does not guarantee stability. It guarantees more stability compared to positive feedback. So everything is in relation. It is in a relative way. It's not absolute way. So in some things open loop system is better, in some other things closed loop is better. In some of the features negative feedback is better, in other features positive feedback is better. In some features PD controller is better, in other features PI controller is better. In some of the aspects transfer function model is good, in other aspects state model is good. So we have to strike a balance in learning all of them with their own merits and demerits. Don't make anything to be absolute. Be with a mindset of relative or comparative study rather than making one to be supreme. No. So one is superior than other. This is the ultimate line that I can tell you. So one is superior than the other, but nobody is supreme. Negative feedback is superior than positive feedback. Negative feedback is not supreme. So there is nobody which I can call it to be supreme in control system. No, I say that it is superior than the other that exists as its counterpart. As far as the transfer function is concerned, we will be asked to find it from a block diagram or from a signal flow graph or from an electrical network or a differential equation whatsoever. But we make use of only one method, that is Mason formula. Finding transfer function either from block diagram or from signal flow graph. I told you, never do the stupidity of entering into the block diagram reduction and trying to modify the block diagram, simplify the block diagram. Never do that. For GATE examination, particularly objective exams, prelims of ES and GATE exam, you just be with the Mason formula. That is the best way possible. So always try to apply Mason formula, whether it is block diagram or whether it is signal flow graph, in order to detect the transfer function from that. Okay. And we have done plenty of the questions of that kind. It's really not necessary to again solve the block diagram signal flow graph, but for namesake and again to recall those things, one question of the block diagram and one question of the signal flow graph I would like to start with. Consider this block diagram representation of a system, say with multiple inputs. One input is the desired R of S. The other input is the disturbance D of S with, let us say, negative feedback given to the system. I would like to have two questions on this diagram. Question number 1. To reduce the effect of the disturbance D in the output of the system, what has to be done? Question number 2. To eliminate the effect of the disturbance D from the output of the system, what has to be done? Be very careful. These two are two different questions. They are not one and the same. One question is to reduce the effect of the disturbance from the system's output, and the other is to eliminate the effect of this disturbance from the system output. Let me take it to be an MCQ. Option A, increase the value of G1. Option B, increase the value of G2. Option C, increase the value of H. Option D, all of the above. For second question, the options that I would like to form: use a PD controller, use a PI controller, use a PID controller, use a feed forward controller. Feed forward controller. These are the options. There are two different questions, okay? On one diagram, I'm forming two different questions. The diagram is this, having multiple inputs, a block diagram. One question, it is to reduce the effect of the disturbance from the system's output. The other is to eliminate the effect of the disturbance from the system output, and the options are given like this. Yeah. See, whenever you have to answer such questions, never do this mistake of forming the output partially. You should always be wise in forming the complete output of the system. I've seen people forming only the output only due to the problem part. सर हमको सिर्फ डिस्टर्बेंस का इफेक्ट रिड्यूस करना है आउटपुट में, तो लेट मी फॉर्म द आउटपुट ओनली ड्यू टू डिस्टर्बेंस. नो, दैट्स वेरी डेंजरस. This way, if you are trying to answer to the question, you are getting misleaded or misleading the people. You always have to form the complete output in case of multiple inputs. Of course, if there is only one input, let us say that there is only one input, and of course output will be only due to that input. But if you have more than one input and you have to answer to a question based on the output of the system, you should always be forming the complete output of the system, then you will get the correct picture. Otherwise, you may end up with the wrong answer. Fine. Output, of course, let's not do all these minor calculations we are aware of by this time. Mason formula. One forward path from here and one forward from this input, and there is only one loop. Using Mason formula, the output here will become G1 G2 R plus G2 into D upon 1 plus G1 G2 H. We know how to deal with this. That's not a problem for us. So, if I write it as two separate components, or let it be the clubbed output totally, we have to reduce the effect of the disturbance from the output of the system. We can do that by increasing the product of G1 G2 H. तो G1 G2 H का पूरा complete product को अगर हम increase करें, तो फिर effect of the disturbance will reduce in the output. But that not only decreases the effect of the output, it also decreases the effect of the input as well. In the question, we are asked to reduce the effect of disturbance only, not of the input or the command. We don't want a harm to happen to the command that we give to the system. The unnecessary inputs that the system assumes, we want to reduce their effect. So thereby, let's not do what is, do that what is common for both the inputs. दोनों के लिए जो common है ना, उसको disturb ना करें. Let me write it separately like this. G1 G2 R upon 1 plus G1 G2 H plus G2 into D upon 1 plus G1 G2 H. Let us not use G2 because G2 is in the numerator as well as in the denominator. It causes equal and opposite effect. If you reduce G2 in the numerator, but that reduction, the G2 in the denominator will cause the value to increase again. Okay, so G2 should not be used. What about H? If I use H, if I increase H, the effect of disturbance decreases, but the effect of command also decreases. So G2 or H, they are not allowed to be used. G2 use नहीं करना है because found in the numerator and denominator. H वो तो R को भी reduce करेगा, तो फिर तो all वाला option तो गया ही. It's only the G1. See, why G1, sir? If I increase G1, the effect of disturbance decreases, but that G1 is found in the numerator and denominator of R. जैसे यहाँ पर G2 डीप के लिए ज़्यादा effective नहीं बना, वैसे G1 R के लिए effective नहीं बनेगा. तो if I increase G1, then only the effect of D in the output reduces, the effect of R almost remains to be the same. This question can be more simply explained like this. If the loop gain G1, G2, H or open loop gain, usually it will be a value which is much higher than 1, usually. In case of the open loop gain of the system is much higher than 1, then I can precisely write this output C as R by H. क्योंकि this part is negligible. So G1, G2 gets cancelled. This part is negligible. Then G2, G2 gets cancelled. So D by G1, H. This is approximate output under the condition that G1, G2, H is much greater than 1. So you can easily understand that I should not be using H, I should be using only G1. Then the effect of D in the output can be reduced. So answer to the question is A. Coming to the second question, to eliminate it. See, I cannot eliminate in this step. If I want to eliminate D, then I should make G1 to be infinity then. But nothing can be infinity in practice. So this way we can only reduce the effect, but we cannot eliminate. To eliminate, we need totally an external solution. See, the very first step to improve the performance of a system is to apply negative feedback. If that is not enough, then we try to adjust the system parameters. If that is still not working, then we try to redesign the system. So that's how we try to improve the system's performance. First we apply negative feedback. Yes, I have applied. Still, the noise effect reduces compared to open loop system, but it is not totally out of the system. So negative feedback can reduce the effect of this disturbance, cannot eliminate it totally. Now we are adjusting the system parameters, increasing the gain G1. It means you are trying to adjust the system parameter. So in spite of applying negative feedback and in spite of adjusting the system parameters, if still you are not able to achieve what you wanted, what is that you want? You want to eliminate. Then you cannot achieve this by negative feedback. You cannot achieve this by adjusting the system parameters. Then sir, what should I do? You should be able to redesign the system by introducing an extra component, which we call it to be controller or compensator. There are many controllers, many compensators that you know. Some of them are named here. But remember, P, R, I, R, D, R, P, D, R, P, D, P, I, R, P, I, D, R, lead, R, lag, R, lead, lag. These are mainly used to overcome the disturbances that are inside the system. For external disturbances, it is the feed forward controller which is recommended. Okay. Proportional controller will usually take care of the error of the system. Derivative controller will take care of the output of the system. Derivative feedback control. PD controller will act on the error of the system as well as the output of the system. Mostly for system variables, whenever there is a disturbance in the system due to the variables of the system, then we make use of this P, I, D controllers, maybe either individually or in combined manner. But when there is a effect of an external disturbance and we want to overcome that, it is the feed forward controller that is recommended. Of course, we have done many questions of this kind. Feed forward controller. Whichever is the variable which is troubling you, that will be fed to this controller as input, and that controller will be fed into the forward path of the control system with some sign, maybe negative or positive. Accordingly, we can design feed forward controller. Pay attention. This way disturbance is +1. This way, if I can make it -1, then the outcome will be totally 0. Disturbance in this path is of unit, say G2, +1 into G2. If I can make it to be -1, let me stop at this adder. यहाँ पर +1 गेन के साथ आ रहा है. अगर यहाँ मैं -1 बना दूँ ना, तो फिर +1 -1 0. There is no gain that this disturbance signal is going to assume to become the output of the system. So how to make it -1? Already minus is there. If I can make GC to be equal to 1 by G1, तो फिर ये 1 by G1 into G1, 1 by G1 into G1, 1 with a minus, -1, +1, -1, 0. So if I can make GC to be 1 by G1, can you design a feed forward controller of value 1 by G1, then you can eliminate the noise from the output of the system. Then that's about it. Moving to the next question. Let me take a signal flow graph. Otherwise, you can take this question. A system is described as x is equal to EY, y is equal to AX plus DZ, Z is equal to CX plus BY. A system is described by these equations, and X, Y, Z are system variables. It is mentioned that X, Y, and Z are system variables. A, B, C, D, E, these are constant coefficients of the system. What is the question? It is to find Z by X. And your options are option A, 1 minus AE by DE. Option B, AB plus C by 1 minus BD. Option C, B plus EC upon C. Option D, all of them. Let us say that this is MSQ. So question may be MCQ, question may be MSQ, question may be numerical data type. It can be any. Suppose if this question is falling under the category of MSQ. Let's see how to deal with this. How to find Z by X? So there are two ways. Either you can implement the relation between the variables of the system which are described in the form of set of linear algebraic equations to be in the form of signal flow graph, and then you can make use of the Mason formula. Otherwise, since there are few equations, why don't you think of simplifying them as it is? See, when do we implement signal flow graph from set of linear algebraic equations and we use Mason formula? When they are huge in number. कोई 10 इक्वेशन है, 15 इक्वेशन है, तब तो इन सिंप्लीफिकेशन सर दर्द का काम है. Better switch to signal flow graph, apply Mason formula and get rid of that. Otherwise, if there are 2 equations, 3 equations, then why don't you think of simplifying the equations directly? Why do you implement that into signal flow graph and then using Mason formula? So, we do use Mason formula as an alternate to block diagram reduction, but there are places where we find an alternate even to the Mason formula. That is, dealing the equation directly. That way. Sometimes it may be lengthy even if I use Mason formula. Right. For example, if there are 3 questions, right? So, 3 equations, I can simplify them. How? Let me put, what is that we have to find? Z by x. Let me put equation 2 into 1. 2 into 1. So, x is equal to Ey, y is ax plus dz. From this, if I take x common, it becomes 1 minus ae is equal to dez. Z by x is 1 minus ae by de. I'm substituting equation 2 in 1 and I'm getting z by x to be this. Now I would like to substitute 2 in 3. Z is equal to cx plus by. B is ax plus dz. Because this is not the only way of simplifying. There is another way of simplifying. Let me try that. If I take z common, it is 1 minus bd is equal to x ab plus c. So z by x here becomes ab plus c by 1 minus bd. As of now, a and b have become right. Let's think of c. So 2 in 1, 2 in 3. Let me try to substitute 1 in 3. Z is equal to cx plus b y. What is y? X by e. Here, some people will get confusion. They have a doubt. Sir, the relation between the variables of the system should be in the form of cause effect. And you said that we should not reverse the role of cause and effect. If this is cause, this is effect, we should never reverse them. Cause becomes effect, effect becomes cause. Yes, the relation between the variables in cause-effect form should not be altered, provided if that cause is an external variable. If it is a system variable, it can definitely be altered. Relation between the system variables where they are dependent variables can be altered. Relation between system variable and external variable should never ever be altered. If y is an external variable, x is a system variable, then writing x is equals to ey as y is equals to x by e is absolutely wrong. But if x is a system variable, y is another system variable, both are variables of the system, none of them is external variable, you can manipulate this as you wish. It is not wrong. Be very clear with the concept. So, z by x is equal to b plus ec upon e. तो C भी सही हो गया, तो आंसर तो फिर all of them. A is the answer, B is the answer. अच्छा ठीक है, if it is D को कुछ और ऑप्शन ले लें क्योंकि all में तब तो हाँ ठीक है, all सही है ना, A भी सही है, B भी सही है, C भी सही है, all of them it is. तो if it is MCQ, I would have chosen simply D. If it is MSQ, now it's all the options which are right. B plus EC upon E. The biggest question that we get in mind is that transfer function is supposed to be unique. Then how can that this z by x is becoming 3 different answers? Yeah, transfer function is unique, but z by x is not transfer function. Because z by x is the relation between 2 variables of the system. Relation between 2 variables is not transfer function. Relation between a system variable and an external variable is transfer function. You should be clear with that. So why this is not unique? Because it is not transfer function. Had it been transfer function, this would have definitely be unique. I mean, those who are interested, what you can do, you can convert these equations into signal flow graph and you apply Mason formula and you can enjoy all these 3 options there as well. So I'm done with this question. moving to the next question. Let me complete this block diagram signal flow graph with this question, because there is a lot that we need to see with other topics. I've seen people struggling a lot with this question. In spite of explaining this with so much of clarity so many times, still people tend to get confused because the concepts get fade away. So many people still struggle with this simple question. The question is to find C by R. C by R pata karna hai. I want you to understand the difference between this question and the difference between this question. That's where the confusion arises. Don't think that these two are one and the same. Question को ठीक से देखें. In this signal flow graph, we have input node, we have output node. You can apply Mason formula directly. Here the answer C by R, it becomes 1 minus 0 upon 1 minus of H1 plus H2 plus H1 H2. That's correct. This is different, for God's sake, have no confusion. We have input node, we have output node, then only we will be able to apply Mason formula directly. Here, we don't have input node, but we have output node. And I have seen people having this, lame excuses or lame discussion saying that इसमें input node भी नहीं है, output node भी नहीं है. How stupid is that? Input node नहीं है, okay, but output node is very much there, yaar. How? A self loop. A loop of this kind is called a self loop. Self loop is always an incoming branch. Self loop is always an incoming branch, wherever you find it. And output node is the one which has got only incoming branches. There is an incoming branch. There is an incoming branch. This is very much output node. Some people try to extend it. Still, you are not going to prove anything. It is the same. This question is same as this question. So this question is same as this question. There is no difference between them. क्योंकि already output node है. अब extend करना हो तो आप 10 कर लो ना. चलो सर एक और लगाता हूँ. एक और लगाता हूँ. वो कौन सा concept हो गया? No. When there is already output node, you don't have to show it again. When there is already input node, you don't have to show it again. When you don't have, then only you need to show. तो इसमें input node नहीं है. Output node is very much there. Now what to do? Either you create the input node and use Mason formula, or why would you trouble Mason every time? It's a very simple question. You can finish it using the equations. तो यहाँ पर मैं Mason formula को भी encourage नहीं करूँगा, क्योंकि it will take 2 minutes, at least, even if you're quick. If I have to explain 5-10 minutes, no, they are 30 seconds, 20 seconds. How? What is output C? Sum of all the incoming branches, R into 1 plus C into H2. What is that you want? C by R. खत्म करो ना कहानी. हो गया. We are here to give GATE exam. You have to be very quick, very smart, very precise. Don't elaborate. Elaborate करके समझाने के दिन गए. In 50-60 hours of the class lecture, वहाँ तो elaborate करके समझाया. अभी भी वही करेंगे 1 week before the exam. No. Be very quick and smart and very simple. In all the questions that I take up, I try my best to be very simple and very quick and very precise with my answers. Answer is 1 by 1 minus H2. Okay, so I think that's enough with the the introduction of control systems, forming transfer function, block diagram, signal flow graph. You have done much, but this some key issues that I would like to address. Now moving to the response analysis. See, step response of a system is given to be 1 minus 2 e to the power minus 2t u of t. Let us say that step response of a system is given to be 1 minus e to the power minus 1 minus 2 e to the power minus t u of t. Yeah, don't expect the questions from me to be in a particular sequence के topic के बाद ये चले. पूरा syllabus हो चुका है, तो now I can take the topic from anywhere in any manner. So don't take it to be a sequence में चलें questions, not necessary. कहीं से भी उठा लो. ये है step response. Question is to find the transfer function of the system. Here, I would like to, you can find, you know that very well, but I want to add some important thing here. At t is equals to 0, the response is not 0. Initial value of the response, the response value at t is equals to 0 is not 0. Here, two cases exist. If the initial value of the response is not 0 at t is equals to 0, Case 1, it may be a system which is not initially relaxed. It means it has got initial conditions. Case 2, it may be a system whose transfer function is proper, not strictly proper. दो केसेस होते हैं. हम तो यूजुअली एक ही केस की बात करते हैं, लेकिन दूसरा केस भी हो सकता है. Two cases. One, if the initial value of the response of the system is not 0, then it can be due to two reasons. Reason number 1, it may be a system which is not initially relaxed. That means which has got initial conditions. Reason 2, it may be a system whose transfer function is proper, not strictly proper. What do you mean by proper? Which has got equal number of poles and zeros. What do you mean by strictly proper? Which has got more number of poles than number of zeros. What do you mean by improper? Which has got more number of zeros than poles. See, when we obtain the response from the transfer function of a system, we do it only for the strictly proper. No partial fractions are applicable for proper and improper. So if it is a proper or improper function, first you need to convert that into strictly proper by dividing the numerator with the denominator, then separate that extra terms. Then for the strictly proper, you take the inverse Laplace transform through partial fractions. That's the procedure. Those extra things which we get by dividing the numerator with the denominator will make the response to be non-zero at t is equals to 0. That's where you have to be careful with. Okay? I mean to say this. Sir, then how do we understand which reason it is? Suppose it is mentioned that, question देखिए, if it is mentioned that step response of a initially relaxed system is given, and if it is this, it means that उसने कह दिया question में कि system is initially relaxed, इसका मतलब initial conditions are 0, still the initial value of the response is not 0, it means that the transfer function of the system is proper, it is not strictly proper. If it is mentioned that the transfer function of a strictly proper system is, step response of a strictly proper system is given, या फिर कुछ और हिंट दे देता है having more number of poles than zeros, या फिर कुछ और हिंट कह देता है having more degree denominator polynomial than numerator degree, या फिर कुछ नहीं कहा, लेकिन ये भी नहीं कहा कि इनिशियल कंडीशन 0 है, ये भी नहीं कहा, क्वेश्चन में कहा ही नहीं है, तो इनिशियल कंडीशन 0 नहीं है और ना कुछ और कहा है, तो फिर ये जो रिस्पांस होगा ना, I mean if by default initial conditions are considered to be 0. If it is mentioned that initial conditions are not 0, then it will be the transfer function of a proper system. Let me solve it in two ways. Case 1, as I said, कि अभी जो दो केसेस मैंने कहा था ना, कि केस 1 हो सकता है कि इनिशियल कंडीशंस आर 0, केस 2 हो सकता है कि इनिशियल कंडीशंस आर नॉट 0. लेट मी टेक दैट केस 1, इनिशियल कंडीशंस आर 0, 0 इनिशियल कंडीशन वाला सिस्टम. Case 2, non-zero initial condition of the system. Non-zero initial condition. Initial conditions are 0. Then, sir, what to do? Transfer function of the system is S into Laplace transform of step response. That is S into 1 by S minus 2 upon S plus 1. This will be S plus 1 minus 2S, 1 minus S upon 1 plus S, or S plus 1. That is all pass system. And all pass, ये कोई strictly proper थोड़ी है, ये तो proper है ये. तो initial condition 0, 0 initial condition. Under that case, the transfer function of the system is this. And if you want to find the step response, you can simply multiply this with 1 by S and take inverse Laplace transform, you will arrive at that. Now let me consider that this is the step response of a system which has non-zero initial conditions. Then, sir, how to deal with this question? It is mentioned that the initial conditions are not 0, but it is not mentioned that what are the initial conditions. What you can do, the value of the step response at t is equals to 0, if you find, you get it to be minus 1. Minus 1. That is the initial condition part of it. Minus 1. Remember, what is a zero input response, ZIR? From the state model, it is phi of t into x of 0. This is what is the zero input response from the state model. What will be x of 0, phi of 0, which is I, into x of 0, small x of 0. Initial condition happens to be the value of the response at t is equal to 0. This is initial condition. And initial condition happens to be the amplitude of the zero input response. Initial condition is the amplitude of the zero input response, and zero input response nature is nothing but the state transition matrix. So what I can say, I can split this step response to be somewhat like this. It is 1 minus e to the power minus t u of t minus e to the power minus t u of t. I can split this step response to be 1 minus e to the power minus t u of t minus e to the power minus t u of t. This is zero state response which is due to the input. This is zero input response which is due to the initial condition. So how do you know that this is only a ZIR? ZIR is due to initial condition which is of value minus 1, and that happens to be the amplitude of the zero input response minus 1 into the e to the power minus t. This is ZIR. This is ZSR. This is only due to the input. This is free from initial conditions. This is free from the input. ये initial conditions से free है. Now at t is equals to 0, this part of the response will be 0. 1 minus e to the power minus t at t is equal to 0 is absolutely 0. This is zero input response. This is transient response. This is steady state response. Put together you can call these to be natural response. This is Phasor response. Is सारी कहानी. Got it? So that now in this scenario, suppose if it is mentioned that non-zero initial condition है, then the transfer function of the system is actually 1 upon s plus 1. यहाँ से निकलेगा ट्रांसफर फंक्शन, क्योंकि वो तो इनिशियल कंडीशन जीरो बना के निकाला जाता है. 1 माइनस ई टू द पावर माइनस टी, इसका जो ट्रांसफर फंक्शन होगा ना वो 1 बाई एस प्लस 1. इस 1 बाई एस प्लस 1 का जो स्टेप रेस्पॉन्स है, इट इज इंटू 1 बाई एस, विच विल एक्चुअली कम आउट टू बी दिस ड्यू टू द इनिशियल कंडीशन ई टू द पावर माइनस टी दैट गेट्स एडेड. सर इफ दिस इज अ ट्रांसफर फंक्शन एंड फॉर स्टेप इनपुट आउटपुट विल नॉट बी दिस. या ऑब्वियसली, क्योंकि this system has got non-zero initial condition. This is total output. This is ZIR plus ZSR in case of non-zero initial conditions. So from transfer function you can get only ZSR, and using in initial condition you need to find ZIR. उसके लिए तो state model से जाना पड़ेगा. That way we will have one more question of this kind. Hope you understood this part. Take another question. Say that step response of a system is 1 minus 10 e to the power minus t u of t. Same thing, if I consider the initial conditions to be 0, then the transfer function of the system, you know what it becomes? It becomes 1 minus 9s upon s plus 1. Suppose if I consider the initial conditions to be non-zero, then what will be the transfer function of the system? The value of the response at t is equals to 0 is minus 9. So I can split this to be 1 minus e to the power minus t minus 9 e to the power minus t u of t. So due to initial condition of value minus 9, the response is minus 9 e to the power minus t u of t is ZIR. And due to the transfer function, now in this case what will be the transfer function, which is from here 1 upon s plus 1. Due to the transfer function 1 by s plus 1 and due to the input u of t, the output is this, and due to the initial condition of value minus 9, the output is minus 9 e to the power minus t u of t. Total output is this. That's how to deal with this question. Let us do reverse. उल्टा करेंगे. Let us say that transfer function of a system is 1 upon s plus 3. Initial condition of the system is, let us say, 2. Question is to find the step response of the system. Unit step response. सवाल क्या है? Transfer function of a system is 1 upon s plus 3. Initial condition of the system is of value 2. Find the unit step response of the system. What to do? Since the initial condition is not 0, output of the system is ZSR plus ZIR. ZSR input से, ZIR initial condition से. This is the transfer function C of S 1 upon S plus 3 into 1 by S, unit step input. What I'm finding is ZSR. This can be written as 1 by 3 into 1 minus e to the power minus 3t u of t. This is the output, but don't get confused. It's not total output. This is only the output due to the input, not due to initial conditions. So this is not my final answer. You have to be careful. 1 by 3 into 1 minus e to the power minus 3t u of t. This is due to the input. Now due to initial conditions are how to find. यह है ZSR. ZIR जो होता है ना, it is x of t notation, phi of t into x of 0. What is phi of t? It is inverse Laplace transform of Si minus A inverse. What is A matrix of the system? First order system है ना, it is this. Phi of t is nothing but e to the power at. This is also e to the power at. What is A? Minus 3. So what is phi of t? E to the power minus 3 t. So what is x of t? E to the power minus 3t into x of 0. What is that? 2. So it is 2 e to the power minus 3t, u of t of course. All of our systems are causal. Whose output depends on the present or past values of the input, not on the future values, only for the positive time. This is ZIR, this is ZSR. So what is the answer to the question? Find step response. 2 e to the power minus 3t plus 1 by 3 into 1 minus e to the power minus 3t u of t. ये है output. That should be my answer. Okay. So what people do, they try to club this. देखो इसको ऐसे भी present कर सकते हैं. Step response of the system is say 1 by 3. ये दोनों same components है ना. It is 2 minus 1 by 3, 5 by 3 plus 5 by 3 into e to the power minus 3t u of t. क्या गलत है इसे लिखने में? You can write it to be 1 by 3, 1 plus 5 e to the power minus 3t u of t. Now recall the previous questions. मान लीजिए किसी ने आपको क्वेश्चन ऐसे प्रेजेंट किया. स्टेप रिस्पांस ऑफ ए सिस्टम इज 1 by 3, 1 plus 5 e to the power minus 3t u of t. Question is to find the transfer function. अब दो केसेस हो सकते हैं इसमें. This response at t is equals to 0 is not 0. This response at t is equals to 0 is not 0. It means it may be the case that the initial conditions are not 0, or it may be the case that the initial conditions are 0 but the transfer function is proper. So it should be made clear in the question. By default we consider the initial conditions to be 0 unless until mentioned otherwise. तो अगर कह दिया कि इनिशियल कंडीशन 0 है तो फिर सीधा इसका लैप्लास ट्रांसफॉर्म अप्लाई करके ऐसे मल्टीप्लाई कर लेंगे, देन यू विल अराइव एट ए प्रॉपर ट्रांसफर फंक्शन. अगर ये कहा कि इनिशियल कंडीशन 0 नहीं है और ये नहीं कहा कि इनिशियल कंडीशन कितना है, if it is mentioned that the initial conditions, a system which is not initially relaxed has this step response, find the transfer function of the system, then you know you have to arrive at this transfer function क्योंकि शुरू तो यहाँ से हुआ था. So what you need to do, you need to find the value of the response at t is equals to 0, that is 6 by 3, 2. So this will be initial condition. So this much you need to separate it from here. So you need to split it to be, you need to split this step response to be 2 e to the power minus 3t. तो जब 5 e power minus 3t से 2 e power हट गया तो फिर बचा 3, 1 by 3 at t is, that much is the initial condition, right? I'm sorry, 5 से नहीं, 5 by 3 से हटा तो ओके 2 e to the power minus 3t जब गया चले जाएगा ना, तो 1 by 3 into 1 minus e to the power minus 3t ही तो बचेगा. इसमें से 2 e power minus 3t निकाल लेना क्योंकि ये तो इनिशियल कंडीशन है. तो फिर जो बच गया वो ZSR है. तो यहां से ट्रांसफर फंक्शन पता कीजिए. दिस इज 0 और t इज इक्वल्स टू 0. जब आप इसका लैप्लास ट्रांसफॉर्म लेके s से मल्टीप्लाई करोगे ना, देन यू विल अराइव एट 1 by s plus 3. दैट्स हाउ टू डील विद इट. दिस इज द कॉन्सेप्ट. I think we are done with this question. Enough discussion. So you have to be. Yeah, there is another way. Sir, is this the only way of solving? Yeah, there are numerous ways. Numerous ways. You can write this transfer function to be y by u. Cross multiply sy plus 3y is equal to u. Inverse Laplace transform dy by dt plus 3y is equal to u. Now take Laplace transform with initial conditions s y of s minus y of 0 is equal plus 3 into y of s is equal to u of s. Okay. Now, y of s, if I take common, it will be s plus 3 is equal to y of 0, 2 plus u of s, 1 by s. So, what is y of s? The output 2 by s plus 3 plus 1 by s into s plus 3. Now, if you take inverse Laplace transform, it will be 2 e to the power minus 3t plus 1 by 3 into 1 minus e to the power minus 3t, u of t. You are arriving at the same story. There are numerous ways. एक तरीका थोड़ी है. What you understand, what you like, you proceed with that. So, let's proceed with other questions now. Let us say step response of a system is given to be 1 plus 0.2 e to the power minus 60t minus 1.2 e to the power minus 10t. Question is to find omega n and zeta of the system. Question is to find omega n and zeta. See, I have seen people doing some lengthy methods. I taught you everything, lengthy and everything. But here particularly, I would like to reiterate those easy methods which of course I already taught you. I am trying to remind you कि एग्जाम के लिए तैयारी कर रहे हो भाई, बहुत करीब आ चुके हैं आप एग्जाम के लिए. Let's not elaborate things. No, let us make things very precise. Right. Sir, omega n और zeta पता करना है. You know what one method? People try to differentiate step response to get impulse response and then arrive at transfer function. Or they get the step response Laplace transform multiply with s to arrive at the transfer function. भाई ट्रांसफर फंक्शन क्यों बना रहे हो यार? ट्रांसफर फंक्शन बनाने के लिए थोड़ी कहा है किसी ने आपसे? नो. देन व्हाट डू यू फॉर्म ट्रांसफर फंक्शन? अनलेस यू आर आस्क्ड टू फॉर्म ट्रांसफर फंक्शन, डोंट डू इट. बट देन सर ओमेगा एंड जीटा कहां से आएंगे? एक्सपोनेंट में जो t का कोएफिशिएंट है ना, ये आइगन वैल्यू, क्लोज लूप पोल. These are eigenvalues. These are poles. Why didn't you form the characteristic equation directly? S plus 10, S plus 60 is equal to 0. Characteristic equation S square plus 70S plus 600 is equal to 0. I don't have to teach beyond this. You should be very careful. S square coefficient should be 1 to find omega n and zeta. तो बाकी कहानी आप जानते हैं. तो let's not waste the most valuable time that we are spending now. Moving to the next question. Few more questions on finding omega and zeta. Say, step response of a system is given to be 1 minus 1.66 e to the power minus 8t sine 6t plus 37 degree. Step response of a second order system is given to be this. Question is to again find omega n and zeta of the system. See, one of the stupid things, I say stupid things, that people do is by comparing this with the step response of standard second order system, 1 minus e to the power minus zeta omega nt by root 1 minus zeta square into sine omega dt plus phi u of t. They compare with this. सर यही तो है ना रिस्पॉन्स, बिल्कुल. बट द मिस्टेक दे ट्राई टू डू इज they try to treat 1 by root 1 minus zeta square to be 1.66 and they try to treat phi to be 37 degree. This is one of the biggest blunders that one can ever do. Don't do this because ये guarantee नहीं है. सर इस क्वेश्चन में मान लीजिए मैंने जीटा पता किया और 1 by root 1 minus zeta square is coming out to be 1.66 आ रहा है सर. What do you say? इत्तेफाक, कोइंसिडेंस. एक होता है ना कोइंसिडेंस, कभी कोइंसिडेंटली मैच कर जाता है. जिस दिन मैच नहीं किया ना उस दिन पता चलेगा तुमको, आज नहीं पता चलेगा. आज तो बहस कर सकते हो 1 by root 1 minus zeta square is becoming 1.66. जिस दिन नहीं हुआ वो दिन मेरा होगा फिर. तो what I want you to understand, never try to rely on the amplitude and phase. Never try to rely on the amplitude and phase of the response because they are not authentic. Reason is, this can be the response of a system which is not standard second order. किसने कहा तुमको ये standard second order system का response है? क्योंकि standard second order system होने के लिए बहुत सारे conditions है भाई. There are so many conditions that gets imposed. S square coefficient should be 1. These two values should be same and there should not be 0. Okay, pay attention. Suppose if these two values are different, then 1 by root 1 minus zeta square need not become 1.66. बिगड़ जाएगा मामला. Suppose if there is a 0 in the system, in the transfer function of the system, ये phi होना बराबर नहीं है क्योंकि when there is an extra 0 in the transfer function that will induce some additional positive phase, then that will disturb this. Standard second order system में जो phi है ना वो ये phi के बराबर होना जरूरी नहीं है in a system which is second order but not standard second order, because this phase can be manipulated by the 0 that we may have in the transfer function of the system. This amplitude may be manipulated by this mismatch of the values if it is not standard second order. So andhadhun mat करें. Be wise enough, be knowledgeable. So I never taught you this way and I never teach you this way. I never encourage you to find zeta from here or from here, क्योंकि सर हम तो जानते हैं ना phi is cos inverse zeta. हाँ, we know phi is cos inverse zeta. बस इस phi को इसके बराबर करने की हिमाकत ना करें. May happen, I'm not denying कि कभी नहीं होगा. अगर स्टैंडर्ड सेकंड ऑर्डर है, पूरा भरोसा है होगा, नहीं तो फिर नहीं होगा. देन सर व्हाट इज द ऑथेंटिक वे ऑफ डूइंग थिंग्स? लेट इट बी स्टैंडर्ड सेकंड ऑर्डर और नॉट. व्हाट इज ऑथेंटिक इज दिस टू. दिस इज अल्फा, दिस इज ओमेगा डी. इसका कोई बिगाड़ ही नहीं पाएगा कोई. दिस आर ऑथेंटिक. ये ओमेगा डी ही होगा, ये अल्फा ही होगा. देन व्हाट? ओमेगा एन इज रूट ऑफ अल्फा स्क्वायर प्लस ओमेगा डी स्क्वायर 10. जीटा इज अल्फा बाई ओमेगा एन. कितना है अल्फा? 8 और ओमेगा एन 10, 0.8. लो बन गया. This is the most recommended way of solving this question, this type of question. Getting it right? Moving to the next question. Step response of a second order system is 1 minus a e to the power minus 5t sine omega t minus 2a e to the power minus 5t cos omega t u of t. Question is to find omega n and zeta. Question is to find omega n and zeta. If you wish to try, you can give it a try. right? So you might have tried. Say this. We can write this step response to be 1 minus e to the power minus 5t sin A cos B plus cos A sin B, right? Sin A cos B, cos A sin B. It's like two phasors. Let me form a phasor diagram to explain it much better. One phasor is of length A in the direction of cosine. Another phasor is of length A, 2A or A. Of course, measured from origin. Cos leads, sin lags by 90 degree. We know that. तो इन दोनों का एक रिजल्टेंट फेजार बनाएंगे जिसका लेंथ होगा रूट ऑफ ए स्क्वायर प्लस 4a² और इसका फेस मेजर करेंगे विथ रेस्पेक्ट टू साइन. सो आई कैन राइट इट टू बी सम इफेक्टिव एम्पलीट्यूड. लेट मी कॉल इट टू बी अल्फा. इसको अल्फा कह देता हूं. साइन ओमेगा टी प्लस फाई. व्हाट इज दैट फाई? tan inverse of 2a upon a, tan inverse of 2. If it is mentioned to be the step response of the standard second order system, then I can proceed now. Let us say that ये है standard second order system. क्योंकि यहां तो ओमेगा का कोई जानकारी है नहीं, ओमेगा डी. चलो, दिस इज अल्फा. यहां से जो फाई मिलेगा मिल जाएगा जीटा, दैट इज cos फाई. See, if I know this omega, I would have never tried to depend on phi. Why I have taken this question? एग्जामिनर कभी आपको मजबूर भी कर देगा, कभी एम्पलीट्यूड से निकालने की मजबूरी कर देगा, कभी फेस से. बट इन दैट केस इट शुड बी स्टैंडर्ड सेकेंड ऑर्डर सिस्टम. If you are trying to tackle the zeta and omega n either from the amplitude portion, that is alpha part, या from the phase portion, it should be strictly standard second order. Otherwise no. Even if it is not standard second order, I can deal, but in terms of alpha and omega, which is omega d is made to be unknown. क्योंकि इससे पहले क्वेश्चन में अल्फा और ओमेगा डी पता है तो ओमेगा एन पता कर लेंगे. जीटा विल बी अल्फा बाय ओमेगा एन. नाउ आई नो ओनली अल्फा, आई डोंट नो ओमेगा. तो अल्फा तो जीटा एंड ओमेगा एन देगा. तो यहाँ जीटा भी है, ओमेगा एन भी है. तो जीटा अगर पता कर लें तो ओमेगा एन यहाँ से मिलेगा. दैट आई कैन फाइंड फ्रॉम हियर. तो जीटा इज cos फाई. So you can find zeta from here, whatever it be that. Then omega n will be alpha by zeta. You can do like this. Alpha is 5. End of the question. Right. Now move to the next question. Let us consider step responses of two different systems to be given like this. Step response of system 1 and step response of system 2 are given. Question is to identify their pole zero pattern या pole pattern. Zeros तो हम नहीं बात करेंगे because nature of response depends on the poles. Okay. These are two step responses, two systems. System 1 ka step response, system 2 ka step response. Question is to identify that how the poles of them are located. These two have got different overshoots. They have got different rise times. They have got different peak times. Then sir, what is that we can look at based on which we can identify the response? Very simple. They have got same envelope. What is common? between these two step responses is their envelope. What is the envelope of the step response? 1 minus e to the power minus zeta omega nt upon root 1 minus zeta square alpha is the primary parameter of the envelopes. So envelope से alpha को पहचानिए and based on that you will be able to complete the question. So these two systems have common alpha. It means they will have common settling time, 4 by zeta omega, and alpha happens to be a real part of the complex poles. Common omega d, common alpha, common zeta, common omega n. So answer to the question is option B. And understand and remember all those damping cases: undammed, underdamped, critically damped, overdamped, the root behavior, etc. So in this little amount of the time, 2 से 3 घंटों में पूरे 60 घंटों का सब्जेक्ट तो पढ़ा नहीं पाएंगे, but through questions I try to touch all of them. Next, transfer function of a system is 3 upon s square plus 2s plus 4. Identify the step response of the system. Option A. Option B. Option C. Step means by default unit step, unless mentioned. Option D. Transfer function of a second order system is 3 upon s square plus 2s plus 4. The question is to identify the step response, that is unit step response of the system. How do we handle this question? How do we approach to understand and solve this question? Think over it. Pay attention. What is the difference between these two questions? Steady state error is non-zero. Here steady state error is 0. Here steady state error is not 0. Here steady state error is not 0. Steady state error is 0. So two options are based on 0 steady state error. Two options are based on steady state error is not 0. What is steady state error? It is the difference between the desired value of the response and final value of the response. Desired value 1, and if the response finally coincides with that, it means final value of the response is also 1. That means steady state error is 0. What is the simplest way in this world to find the steady state error? Is 1 minus closed loop DC gain for step input. Believe me, there is no other simple approach other than this. This is applicable for unity feedback, non-unity feedback, positive feedback, negative feedback. CC के लिए भी applicable है. If the input is step, the simplest way to find the steady state error is 1 minus closed loop DC gain, irrespective of all this nonsense that which is the feedback used and whether it is unity, non-unity, negative, positive, sub bakwas. 1 minus closed loop DC gain. That's all. So what is closed loop DC gain of this system? More about steady state error, of course, I'll take up. Let me first finish this response case. Steady state error of the system is 3 by 4, 0.75. I'm sorry. Closed loop DC gain is 0.75. Steady state error in the system is 0.25. 1 minus 0.75, that is 0.25. Steady state error of the system is not 0. That means this is wrong option and this is wrong option. B or C has to be the right option. What is the further difference between B and C? Here, the transient response is going beyond 1. Yani MP is peak value of the response is more than 1. Peak value of the response is more than 1. That's what it is here. Here, peak value of the response is less than 1. Peak value of the response. See, If the DC gain of your system is 0.75, it means that the final value of the response will be less than the desired value. So is the effect not only on the final value of the response, for all the values of the responses. Let me explain the question in this way. I raise this one option, I replace to right. Now we have to discuss between B and C. Suppose if the transfer function of the system is standard second order, that is 4 by s square plus 2s plus 4. This is not standard second order, but this is standard second order. So what exactly is this? This is this multiplied by 3 by 4. Okay, this is standard second order multiplied by 3 by 4. We know that the step response of standard second order system, unit step response, is 1 minus e to the power minus zeta omega nt by root 1 minus zeta square sine omega dt plus phi u of t. This is for unit step response of standard second order. Input is still unit step, but this discrepancy or this factor will definitely join the system. So this is the step response of the system now. For unit step, this is the response, 3 by 4 into 1 minus e to the power this thing. What is omega n of the system? 2. What is zeta of the system? 0.5. What is MP of the system? 0.16. Okay. इस सिस्टम के इसकी बात हो रही है, ओमेगा इंटू जीटा 0.5. उसके लिए अगर आप पीक ओवरशूट कैलकुलेट करेंगे तो 0.16. पीक ओवरशूट किसको कहते हैं? इट इज द वैल्यू ऑफ द रेस्पॉन्स विच इज मोर देन 1. ओके, तो ये होना चाहिए 1.16. मैं इस सिस्टम की बात कर रहा हूं, इसकी बात कर रहा हूं. दिस हैज टू बी द यूनिट स्टेप रेस्पॉन्स ऑफ द सिस्टम एंड द स्टडी स्टेट वैल्यू और फाइनल वैल्यू ऑफ द रेस्पॉन्स हैज टू बी सेम एज इनपुट वैल्यू, क्योंकि इसका डीसी गेन तो 1 है, इसका डीसी गेन 1 है, तो फिर स्टडी स्टेट एरर 1 माइनस 1 होके 0 आ जाएगा. दिस हैज टू बी द रिस्पांस ऑफ दिस सिस्टम, बट योर सिस्टम इज दिस विच इज दिस सिस्टम मल्टीप्लाइड बाय 3 by 4. तो रेस्पॉन्स का हर हिस्सा 3 by 4 से मल्टीप्लाई होगा. इट मीन्स ये तो इनपुट है, रहेगा 1. फाइनली आउटपुट जो 1 है ना, तो फाइनली आउटपुट जो 1 है दैट बिकम्स 1 इंटू 3 by 4. पीक वैल्यू ऑफ द रेस्पॉन्स जो 1.16 है ना, दैट बिकम्स 1.16 इंटू 3 by 4. ये सब के सब, not only these two values, response at every instant gets affected. So 1.16 into 0.75, 0.87. So peak value of the response will become 0.87 and final value of the response will become 0.75. This is your answer. Answer is C, not B. We get tempted with that. चलो ठीक है, B तो B में स्टडी स्टेटस 0 नहीं था, 2 ऑप्शंस बचे थे, लेकिन पीक वैल्यू ऑफ द रिस्पांस तो 1 से ज्यादा है ना, वो तो हो ही नहीं सकता. हियर पीक वैल्यू ऑफ द रिस्पांस इज 0.87, फाइनल वैल्यू ऑफ द रिस्पांस इज 0.75. सर, व्हाट इज MP? टेल मी व्हाट इज द डेफिनेशन ऑफ MP? MP is the difference between peak value of the response and final value of the response. ये है ना MP definition. How much is that? 0.12. इसका जो MP है ना वो 0.16, लेकिन इसका जो MP है it has to be multiplied with 3 by 4. So this MP has to be multiplied with 3 by 4. 0.12 into 3 by 4. I'm sorry. इसको क्यों multiply करेंगे? 0.12 is our answer, but how do we get? इसका जो MP है ना 0.16, 0.16 has to be multiplied by 3 by 4, क्योंकि इसका MP 0.16, लेकिन जब ये 3 by 4 है तो वो भी 3 by 4 multiplication में आएगा. This becomes 0.12. You can check it out. 0.16 into 0.75 is 0.12. So this is the response plot and all these things. तो इससे MP को भी समझाना था मेरे को. Yeah, if you understood this, let me move to the next question. What is the definition of MP? It is C of TP minus C of infinity for unit step. If it is step, then we multiply this with input amplitude A. Fine. What is the definition of percentage MP? It is nothing but normalized MP multiplied by 100. Here I would like to add an important twist over here. Peak value of the MP is the difference between peak value of the response and final value of the response. Percentage MP, normalized MP, is the difference between peak value of the response and final value of the response divided with the final value of the response into 100. These two formulas we know. For any input amplitude, this is percentage MP. Now, there is an issue with the final value of the response. मान लीजिए, if the final value of the response is same as input value, that is steady state error of the system is 0. This is MP. This is MP. Difference between peak value and final value of the response. What is percentage MP? You need to divide MP with the final value of the response. If the input value and final value of the response is same, that means steady state error is 0, then it is the final value of the response with which you need to divide, or the input value with which you need to divide. They are one and the same. Sometimes what happens, the final value of the response will not become same as input value. वही चक्कर था previous question में. In previous question what we saw that final value of the response is 0.75. Input value 1. Steady state error is not 0. It was 0.25. Now, what is MP? चलो MP के लिए तो हमने define कर दिया. What is MP of that system? MP of that system is, it is the difference between peak value of the response, which was 0.87. इस question में previous question की बात हो रही है. Minus final value of the response 0.75, that is 0.12. ये MP. What is percentage MP? Percentage MP is nothing but MP multiplied by 100, 12%. Fine. For unit step input. Now, if it is 4 units of the step, as a matter of example, मैं इसको 4 units of the step पे लेके जाता हूँ. You have to be very careful and very clear with this. Let the input be 4. Then, what will be peak value of the response? 4 into 0.87. What will be final value of the response? 4 into 0.75. Then what will be MP? 4 into this, 4 into this. That means into 4. In this case, your MP becomes 0.48. Correct. MP of this system for 4 units of the step, it is 0.48. For 1 unit of the step, 0.12. What about percentage MP? It still should be 12%. We know that MP has no, percentage MP has no effect of the input amplitude. लेकिन calculate करे तो भी वही आए ना. I know that MP changes proportionally with respect to input amplitude, but percentage MP will remains to be the same. तो अगर मैं calculate भी करूं तो यही साबित करूं. ये ना कहूं कि पहले से मेरे को पता था 12% है तो अभी भी 12% ही रहेगा, अच्छी बात है, लेकिन सॉल्व करके दिखाएं सर. ये तो यूनिट स्टेप इनपुट के लिए था. Now how to find? Percentage MP is nothing but difference between peak value of the response. What is the peak value of the response now? 4 into 0.87 minus final value of the response 4 into 0.75 divided by, यहाँ पर मेरे को स्ट्रेस करना है, percentage MP is defined to be C of TP minus C of infinity upon C of infinity. Okay. तो अब जो C of infinity है ना, it is how much? 4 into 0.75. Correct. So how much that becomes? C of infinity. So is that coming out to be 4.87 into 4, 3.48 minus 3, 0.48. This becomes 0. Of course that is MP only, divided by 4 into 0.75. 4 multiplied by 0.75, 3. 0.48 by 3 आ रहा है. 0.48 divided by 3 is 0.16 into 100, 16% आ रहा है, लेकिन ये तो सरासर गलत है. That's what I would like to stress. 16%. We know one thing, that MP changes proportionally with input amplitude, but percentage MP should not change, does not change. तो जब MP 0.12 है यूनिट स्टेप इनपुट के लिए, 4 यूनिट्स ऑफ द स्टेप के लिए 0.12 इंटू 4 0.48 होगा. तो जब यूनिट स्टेप के लिए MP 0.12 है और परसेंटेज MP 12% है, 4 यूनिट्स ऑफ द स्टेप के लिए 0.48 जरूर होगा, लेकिन ये 12% ही होना चाहिए. लेकिन कैलकुलेट करके देखूं तो ये कुछ और ही आ गया. Sir, where is the problem? Where is the mistake? The mistake is you are dividing with C of infinity, that is final value of the response. ये गलत है. You actually have to divide with the input amplitude. क्योंकि 0.87 minus 0.45 0.12 जब 12% बना, और अगर ये 12% बाकी रहना हो ये 4 गुना बढ़ने के बावजूद, तो फिर 4 से डिवाइड करना है, ना कि 4 into 0.75. So please understand the concept of percentage MP. If the steady state error of a system is 0, then whether you divide with final value of the response or the input value, it is the same thing. But if the steady state error of a system is not 0, and if you want to calculate percentage MP, it is the input value with which you need to divide, not with the final value of the response. So this will be C of infinity if steady state error is 0, but this will be A, that is input amplitude, if steady state error is not 0. That's the excellent thing that I would like to introduce here. Otherwise, percentage MP also changes, but that is stupid, absurd. Percentage MP change नहीं होना चाहिए if you change the input amplitude. तो normalized किसको कह रहे हैं आप? किससे normalize कर रहे हैं? Input amplitude से. Coincidentally, input and final value response become same in case of 0 steady state error. जब steady state 0 नहीं होगा तब पता चलेगा it's not that what you have to do, it is something else. So remember, MP changes due to input amplitude, MP changes due to closed loop gain, MP changes due to open loop gain. Percentage MP does not change due to input amplitude, percentage MP does not change due to closed loop gain, percentage MP changes only due to open loop gain. तो परसेंटेज एमपी सिर्फ एक चीज के वजह से हरकत में आएगा, दैट इज ओपन लूप गेन. क्लोज लूप गेन से या इनपुट एम्पलीट्यूड से परसेंटेज एमपी चेंज नहीं होगा. एमपी तो हर उस चीज से चेंज हो जाएगा जो आप वेरी करोगे. तो द थिंग, तो आंसर 12% कब होगा भाई? 0.4 इंटू 0.759 जब तो आप 4 से डिवाइड करोगे. सो इट विल बी 4, देन इट बिकम्स 0.12, दैट इज 12%. करेक्ट? Yeah, I'm done with that question. Moving to the next question. Step response of a system is given, and this is given for 5 units of the step. Question is to obtain the transfer function of the system. Let us consider that this is the step response of a first order system. Option में होंगे तो सारे ही first order होंगे. This is non-oscillatory. Undamped second order is sustained oscillations. Underdamped second order exponentially decaying oscillations. Critically damped or overdamped second order will be non-oscillatory. Sorry, critically damped भी हो सकता है, overdamped भी हो सकता है, other second order or maybe first order. Yes, the clarity should be given in the question. Let us say that this is of the transfer function of a first order system. Step response of a system is given. Question is to find the transfer function of the system. So what is given? Steady state error is 1. Steady state error 1 का मतलब हो गया Steady state value of the response is 4 because input value is 5. 5 minus 4 is 1. Steady state value of the response 4 होने का मतलब हो गया DC gain of the system is 4 by 5, 0.8. ये है DC gain. Final value of the response is 4. To a value 2.5, the response is reaching in 3 seconds. 2.5 is 63% of 4 होता है. The time in which the step response reaches to 63% of the final value will be the time constant of the system. So, the transfer function of the system, we know of the standard first order system to be 1 upon Ts plus 1. Closed loop DC gain of this system is 1, but this is the response of a system whose closed loop DC gain is 0.8. So, you need to multiply this with 0.8 and you need to put T is equals to 3 over. Yeah, let me address to this critically damped systems settling time. Some people will have the confusion with this. Sir, you said that settling time for 2% criteria, it is 4 upon zeta omega n. Yes, but this is for underdamped. See, I told you many times that the formulas of underdamped system should not be used outside the system. There is a second order underdamped system without 0. There is a second order underdamped system with 0. When the formulas are not applicable because of a 0, then how can the formula be applicable if the system itself is not underdamped? Underdamped है, लेकिन अगर उसमें कोई 0 आ जाए तो जो formulas अप्लाई नहीं होंगे, तो फिर जब सिस्टम underdamped ही नहीं है तो फिर यार कहाँ से अप्लाई होंगे? इतना तो कॉमन सेंस होनी चाहिए, है ना? क्रिटिकली डैम्ड या ओवर डैम्ड है, फिर भी यही फॉर्मूला जिद पे आके अप्लाई कर रहे हो. हाउ डू यू अप्लाई दैट? 4 by zeta omega n. This is the formula for underdamped system for 2% criteria. If your system is overdamped or critically damped, then you should not use this. Then what to be used? In case of overdamped system, we use the formulas of first order based on the dominant root concept. That is also over. Undamped system is not stable, so there is no response analysis. बात रहेगी सिर्फ critically damped system के, and for that, no rise time, no peak time, no peak overshoot. There is only one formula, that is settling time. Critically damped system कहीं rise होना, कहीं peak होना, कहीं settle होना, ऐसा नहीं करेगा like an underdamped system. जहाँ rise करेगा, जहाँ peak करेगा, वहीं settle भी करेगा. ये इसकी खासियत है. Critically damped system, we have discussed all this. Critically damped system is defined for only one parameter, that is settling time. So if at all if there is a question about critically damped system, it will be about its settling time. How much it will be? Very simple. You need to derive. You need to derive. If it is not standard second order system, then no formula is applicable. The formulas that I gave you are for standard second order system. If it is not, then don't use the formulas. Then what? Every other system has to be addressed through derivation. तो एक बार इसका देख लें आप. What is the standard second order system closed loop transfer function? Not a big thing. Very simple. It is this. Critically damped system means zeta is equal to 1 unit step response. If you obtain that, it will be 1 minus e to the power minus omega nt into 1 plus omega nt. That's all. This is the critically damped system step response. Suppose if you are talking about 2% criteria, it means this response has to become equal to 90% of its final value, which is 1. That will become 6 by omega n because इसका zeta 1 है. यहाँ पर लोग बड़ा कंफ्यूज हो जाते हैं, बहुत परेशान हो जाते हैं. सर आपने कहा कि क्रिटिकली डैम्प्ड सिस्टम इज द वन विच हैज गॉट द लीस्ट सेटलिंग टाइम. आपने कहा क्रिटिकली डैम्प्ड सिस्टम इज द वन विच हैज गॉट द स्मॉल टाइम कांस्टेंट. आपने कहा क्रिटिकली डैम्प्ड सिस्टम इज द वन विच इज फास्टेस्ट एंड मोर स्टेबल देन एनीबडी. हम वो पोल लोकेशन भी तो देखते हैं कि अनडैम्ड सिस्टम के पोल यहाँ है, अंडर डैम्ड यहाँ है, क्रिटिकली डैम्ड तो सबसे लेफ्ट में है. So according to the concept of stability, if the poles are in the deep left side of S-plane, that system is more stable than a system whose poles are to the right of it. So among undamped, underdamped, critically damped, it is a critically damped system which is of highest stability. Of course, overdamped का एक पोल deep left side में होगा, दूसरा horizon के करीब होगा, या dominant pole है जिसके वजह से we don't recognize its characteristics to be good. बट सवाल ये उठता है कि सर फॉर 2% क्राइटेरिया सेटलिंग टाइम हैज गॉट आई मीन सेटलिंग टाइम ऑफ अंडर डैम्ड सिस्टम इज 4 बाई जीटा ओमेगा एन, यहाँ पर सेटलिंग टाइम ऑफ क्रिटिकल डैम्ड सिस्टम इज 6 बाई ओमेगा एन। इन दोनों का ओमेगा एन अगर हम सेम रख लें, लेट ओमेगा एन, क्योंकि कांस्टेंट होता है ना सिस्टम का, लेट ओमेगा एन बी 1, तो ये तो 6 सेकेंड हो गया। और अगर हम जीटा को 0.5 लेंगे फॉर एग्जाम्पल, तो ये 8 सेकेंड हो गया। और लोग ये भी तो कहते हैं कि इफ द जीटा इज ग्रेटर दैन 2/3 समथिंग लाइक 0.66, तो क्रिटिकल डैम्ड सिस्टम का सेटलिंग टाइम ज्यादा हो जाएगा, अंडर डैम्ड का कम हो जाएगा। पता नहीं किधर किधर क्या मतलब कंफ्यूज करने की कोशिश करेंगे लोग। पे अटेंशन, people try to say that if zeta greater than 2/3 yani greater than 0.66, then they try to arrive at a conclusion that settling time of under damped system is less than that of critically damped. क्या बताऊं मैं आपको, मान लो zeta 0.7, then 4/0.7 कितना होगा भाई, 4 divided by 0.7, 5.7, जीटा 0.5 हो तो 8, अगर जीटा मान लीजिए 0.7 है, और आपने भी कहा था सर लिमिटिंग वैल्यू ऑफ जीटा 0.4 से लेके 0.7 तक होगा, अगर मैं जीटा 0.7 ले लूं तो फिर ये तो 5.7 सेकेंड्स हो जाएगा। सो देखिए सर, अंडर डैम्ड सिस्टम का जो सेटलिंग टाइम है फॉर जीटा इज इक्वल टू 0.7 फॉर 2% क्राइटेरिया 5.7 सेकंड्स हो रहा है, बट इन द सेम सिस्टम इज क्रिटिकल डैम्ड सिस्टम फॉर द सेम नेचुरल फ्रीक्वेंसी ऑफ ऑसिलेशन दैट इज 1 सेकंड फॉर द सेम 2% क्राइटेरिया, द सेटलिंग टाइम कम्स आउट टू बी 6 सेकंड, सेटलिंग टाइम ऑफ द अंडर डैम्ड सिस्टम लेस देन दैट ऑफ द क्रिटिकल डैम्ड सिस्टम। माइंड ब्लोइंग सर, यहाँ तो मामला उल्टा ही करके दिखा दिया किसी ने कि आपने कहा था और सब कहते हैं कि सेटलिंग टाइम इज इनवर्सली प्रोपोर्शनल टू स्टेबिलिटी, मोर इज द सेटलिंग टाइम लेस इज द स्टेबिलिटी, लेस इज द सेटलिंग टाइम मोर इज द स्टेबिलिटी, less is the settling time, more is the stability, more is the settling time, less is the stability। सर आपने तो कहा था कि अंडर डैम्ड सिस्टम से ज्यादा स्टेबल होता है क्रिटिकल डैम्ड, और वही दिख रहा है पोल के लोकेशन से, लेकिन यहां तो सेटलिंग टाइम के नजरिए से देखें तो उल्टा ही हो रहा है। हाउ टू डाइजेस्ट दिस कॉन्सेप्ट, क्योंकि कंट्राडिक्ट कर रहा है ना। विद रिस्पेक्ट टू लोकेशन ऑफ द पोल क्रिटिकल डैम्ड इज मोर स्टेबल दैन दैट ऑफ अंडर डैम्ड, बट विद रिस्पेक्ट टू सेटलिंग टाइम फॉर दिस पर्टिकुलर कंडीशंस under damped system is more stable than critically damped. Sir, how to believe in? It is absolutely the critically damped system which is definitely more stable than of under damped system, irrespective of all these stupid calculations or the values. The reason is critically damped system is not only recognized by the settling time, it is also recognized by no overshoot. The most important thing which you are missing. यार तुम कुछ भी कर लो, क्या इसका MP 0 है भाई? नहीं ना, इसका MP 0 है यार। Relative stability is not studied not only through settling time but also through MP. आप MP और settling time दोनों को बेस करके बात कीजिए ना ऐसे सिस्टम में। You take only MP or only TS between two under damped systems. You take only MP or only TS between two critically damped system. दो under damped है, take TS enough, या take MP। दो critically damped है, take only TS enough। एक अंडर डैम्ड है, दूसरा क्रिटिकली डैम्ड है, सिर्फ टीएस लेके बात करें तो बेवकूफी है, तभी तो कंफ्यूजन आएगा। देन सर हु इज मोर स्टेबल? क्रिटिकली डैम्ड सिस्टम इज मोर स्टेबल, दो द सेटलिंग टाइम इज मोर, इट इज 6 सेकंड सेटलिंग टाइम विदाउट एनी ऑसिलेशंस, दिस इज 4 सेकंड सेटलिंग टाइम विद ऑसिलेशंस। ऑसिलेशंस आर इनवर्सली प्रोपोर्शनल टू स्टेबिलिटी। भाई इसकी जो स्टेबिलिटी है ना, इसमें ऑसिलेशंस खत्म है ही नहीं, होंगे फाइनली, लेकिन इसमें तो ऑसिलेशंस रहेंगे। इसका MP 0 नहीं है। फॉर दिस वन you will get MP to be maybe around 0.1, 0.2. तो इसमें तो MP absolutely 0. So critically damped system को कभी भी किसी क्वेश्चन में देखो आप कैसे कहते हैं, critically damped system is the one which has got no oscillations and least settling time. Under damped system cannot be said as no oscillations. तो इसके एक ये जो खूबी है ना, इसके वजह से ज्यादा स्टेबिलिटी होता है। ऑसिलेशंस आएंगे नहीं, हाँ सेटलिंग टाइम भले आपको ज्यादा लग रहा हो, लेकिन स्टेबिलिटी में जब बात करें तो इन दोनों के बेस पे बात करेंगे तो दिस इज मोर स्टेबल दैन दैट वन बी कंसेप्चुअल। Done with it? Okay. Moving to the next question. I think that should be enough regarding the, cases of damping, etc. Few questions of steady state error let me take. Let me give you another interesting way of finding the steady state error. See, what is the closed loop transfer function of standard second order system? Omega n square upon s square plus 2 zeta omega n s plus omega n square. How do we find steady state error? We obtain the open loop transfer function, subtract the numerator from the denominator, see the type of the system and use the table. वो सब कहानी पता है. Let me not reiterate things. Another simple way. How to find steady state error? Directly from the closed loop transfer function. For step input, only for step input, 1 minus closed loop DC gain. Another, pay attention. इसको A0 कहूँ, इसको A1 कहूँ, इसको A2 कहूँ, इसको B0 कहूँ, B1 और B2. Where B0 is this, B1 is 0, B2 is 0. In this system, A0 is this, A1 is this, A2 is this. For step input, chalo, amplitude A. Steady state error is A0 minus B0 by A0. For ramp input, steady state error is A1 minus B1 by A1. For parabolic input, steady state error is A2 minus B2 up. My mistake. ये A0, ये भी A0, सब में A0. Listen, if this is 0, use this formula. If this is not 0, this formula is wrong. क्योंकि steady state error cannot be finite for two different inputs. ये 0 है तो ये सॉल्व कीजिए. अगर ये 0 है तो फिर ये फॉर्मूला यूज कीजिए. अगर ये 0 नहीं है तो फिर ये फॉर्मूला गलत है. स्टेप के लिए 0 है तो फिर रैम के लिए फाइनाइट होगा, पैराबोला के लिए इनफाइनाइट. स्टेप के लिए 0 है, रैम के लिए भी 0 है, तो जाके पैराबोला के लिए फाइनाइट होगा, और 0 भी हो सकता है. व्हाट आर द कॉम्बिनेशंस? 0 0 0, या फिर 0 0 फाइनाइट, या फिर 0 फाइनाइट इनफाइनाइट, या फिर 0 इनफाइनाइट इनफाइनाइट. इट नेवर हैपेंस कि तीनों फाइनाइट या फिर तीनों इनफाइनाइट. नो नो, राइट? तो यूज इट वेरी केयरफुली. फॉर एग्जाम्पल, फॉर स्टेप इनपुट कितना होगा? ओमेगा एन स्क्वायर माइनस ओमेगा एन स्क्वायर बाय ओमेगा एन स्क्वायर, 0. Since it is 0 for step input, dare to use this formula for ramp input. A1, 2 zeta omega n minus 0, B1 na, upon A0, it is 2 zeta by omega n. For parabolic, infinity. स्टेप के लिए 0 है तो रैम के लिए फाइनाइट होगा. अगर रैम के लिए फाइनाइट है तो पैराबोलिक के लिए इनफाइनाइट होगा. डोंट यूज दिस फॉर्मूला. डोंट यूज दिस फॉर्मूला. ये कब यूज करेंगे? अगर रैम के लिए भी 0 है तो फिर पैराबोला के लिए फाइनाइट होगा. As a matter of example, transfer function of a system is s plus 1 upon s square plus s plus 1. ये B0 है, ये B1 1 है, B2 0. ये A0 है, ये A1 है, A2 1. स्टेप वाला फॉर्मूला यूज कीजिए. 1 minus 1 by 1, 0. ये 0 हुआ तो तब जाके मैं ये फॉर्मूला यूज करूंगा. व्हाट इज दिस? 1 minus 1 by 1, 0. जब ये भी 0 हो रहा है, देन आई डे टू यूज दिस फॉर्मूला. अगर ये फाइनाइट होगा, लाइक द प्रीवियस क्वेश्चन, मैं यहाँ इनफाइनाइट जवाब दूंगा. आई डोंट यूज द फॉर्मूला. यहां पर क्या होगा? इट इज A0 1 minus A2 1, B2 0 by A0 1. इट इज 1. तो इस सिस्टम का स्टडी स्टेटस स्टेप इनपुट के लिए 0, रैम्प इनपुट के लिए 0, पैराबोलिक इनपुट के लिए 1. सर ये क्या सही है? चेक इट आउट. व्हाट इज द ओपन लूप ट्रांसफर फंक्शन ऑफ दिस सिस्टम? s plus 1 upon s square. व्हाट इज द टाइप? टाइप 2. टाइप 2 सिस्टम का स्टडी स्टेटस स्टेप इनपुट के लिए 0, रैम्प इनपुट के लिए 0, पैराबोलिक इनपुट के लिए क्या होगा? 1 by ka. If the input is of amplitude a, then a by ka. What is ka? इसका DC गेन. Limit s tends to 0, s square, s plus 1 by s square, 1. Steady state error 1. हो गया ना? यानी क्लोज लूप ट्रांसफर फंक्शन से straight away, if you want to find the steady state error, this is another way. If you don't like, you can go to open loop transfer function and find it from there. Take another question. Let us say transfer function of a system is ks plus beta upon s square plus alpha s plus beta. You want to find the steady state error of the system for unit step input. How simple it is. 1 minus closed loop DC gain. भाई एक सेकेंड का जवाब है. Not 10 minutes, not 5 minutes, 1 second. 1 minus closed loop DC gain. कहानी खत्म, क्योंकि closed loop DC gain इसके. Or you can do like this. A naught minus B naught. Beta. A naught. हाँ. Beta minus B naught. K beta by beta. 1 minus K. Done? So I'm addressing to the simple ways of doing things. Other ways, of course, you know. Take another question. Open loop transfer function of a system is K upon SS plus A. Question is to find the sensitivity of the steady state error of the system with respect to K and A. With more practice, you know, things becomes more clear. You need to have practice. There is no other substitute to practice. For ramp, सर कौन से इनपुट के लिए नहीं बताया भाई. टाइप 1 सिस्टम का स्टडी स्टेट रैंप इनपुट के लिए ही फाइनाइट होगा. अगर स्टेप या पैराबोलिक इनपुट होगा तो फिर वो जीरो इनफाइनाइट होगा. तो फिर देयर इज नो वे दैट यू कैन टॉक अबाउट द सेंसिटिविटी विद रिस्पेक्ट टू पैरामीटर. You're trying to talk about the sensitivity of a function with respect to a parameter where the function is zero, which is independent of the parameter. तो फिर sensitivity भी zero हो जाएगा. तो अंडरस्टूड. तो ये जो स्टडी स्टेट एरर है ना इस सिस्टम का रैंप इनपुट के लिए a by k आएगा. यार why to solve? Be wise. Steady state error proportionate to a, inversely proportionate to k. ये पॉजिटिव होगा या नेगेटिव होगा. By what extent? 100%. 100%. कैसे? a डबल होगा तो ESS भी डबल होगा. k आधा होगा, k डबल होगा तो ESS आधा होगा. Steady state error is 100% sensitive with respect to k but negatively. Steady state error is 100% sensitive with respect to a positively. Answer is -1 or +1. लो कहानी खत्म. We know formulas, but I don't want to use formulas. Why? Answer is important, not the procedure in objective exams. Considering the transfer function of a system to be 5s plus 1 upon s square plus 2s plus 5. Say, question is to find the rise time of this system, or maybe peak time of the system, or maybe peak overshoot of the system, whatever. Question is to find this. And the mistake that we may commit is by using the formulas directly. First of all, such question is not supposed to come in objective exam because it takes a bit time in developing the response. ये second order जरूर है लेकिन इसमें zero है भाई. The moment when you see zero in the system, it is not standard second order. Then for God's sake, don't use the formula of rise time as pi minus phi by omega d, or peak time to be pi by omega d, और MP का जो formula है ये गलत है, not applicable. Then sir, what is applicable? Because of this zero, your response will have additional positive phase. इसका जो step response आएगा ना, if you derive 1 minus root 5 e to the power minus t cos 2t plus phi आएगा. ये आएगा. In the step response of standard second order system, we have sine function. But in the step response of this system, we got cosine function. When sine becomes cosine, sine theta plus 90 degree is cos theta. Sine 90 plus theta is cos theta. A zero responsible for a maximum phase of plus 90 will change the sign from standard second order system into cosine, which is not standard second order. So the result is evident there. तो 90 degree का फर्क होगा. तो फिर sir, what is the correct rise time? Pi by 2 minus phi by omega d. What is the peak time? Pi by 2 by omega d. Peak overshoot, इसको तो solve करना होगा. C of TP minus C of infinity बना के. So what I want you to be careful, there are very less chances, to an extent of that not even 0.1% of the chance you have got to get this type of question in the objective exam. If at all if you get, then there is no way in answering to the question other than getting the response of the system and then getting it from that. But these formulas, these two, I can help you out with that. 90 degree कम करके ले लेना, pi by 2 minus phi by omega d, pi by 2 by omega d, MP के लिए derive करना, settling time के लिए derive करना पड़ेगा. Be notified about this. Okay. This is about first and second order system. Suppose if at all if a question of a third order system comes into picture, then sir, how to deal with that? मान लीजिए characteristic equation of a system is s cube plus 6s square plus 13s plus k is equal to 0. We make use of the dominant root concept, right? For third order system, we consider to be cascade combination of first and second order system, with the second order being dominant, and we deal with the question based on the dominant second order. That's fine. This is the characteristic equation of a system. Question is to find a k, say for the settling time of the system to be 4 seconds. How do we solve this? We consider this system to be s plus a, s square plus bs plus c is equal to 0. What is b? 2 zeta omega n. What is c? Omega n square, because this is dominant second order. What is settling time? 4 by zeta omega n, 4 seconds. That means zeta omega n is equal to 1. So b value becomes 2. Now we compare these two equations. After writing this in proper form, cubic for polynomial, we will get the unknown. That is one way of doing this question. There is another way of doing this question. If you want the settling time to be 4 seconds, the dominant roots of the characteristic equation must be lying on s is equal to minus 1 line in s plane. If this is how the roots of the third order system are, first order dominant, first order ordinary, second order dominant, and the real part should be minus 1 as shown here. That means the roots should lie on s is equals to minus 1 line. Then you will arrive at the condition. What you can do, you can replace s with s minus 1 and obtain the modified characteristic equation. And that characteristic equation, after replacing s with s minus 1, becomes s cube plus 3s square plus 4s plus k minus 8 is equal to 0. For the roots to be on the line, apply Raoult array to this and equate s power 1 rho to 0. For the roots to be on this line, replace s with s minus 1 and obtain this, and apply Raoult array to this and equate s power 1 rho to 0, which is nothing but, in short, BC is equal to AD. K minus 8 is equal to 12. K is equal to 20 is the answer to the question. Two ways. What approach you want to adapt? That is your choice. Right. Now, moving to the next question. Finding the, let me summarize the effect of various controllers and compensators on system parameter, thereby response parameters. See, proportional controller क्या करेगा? When you bring it into a second order system, it will reduce it will increase omega n by root k. It will reduce zeta by root k or root kp. ओमेगा n रूट के पी टाइम्स बढ़ेगा, जीटा रूट के पी टाइम्स घटेगा. स्टडी स्टेट एरर ये के पी टाइम्स रिड्यूस हो जाएगा. ये प्रोपोर्शनल कंट्रोलर. व्हेन यू ब्रिंग डेरिवेटिव कंट्रोलर, व्हाट हैपेंस? डेरिवेटिव कंट्रोलर ओमेगा n को सेम ही रखेगा, जीटा को बढ़ा देगा बाय वैल्यू के डी ओमेगा n बाय 2, स्टडी स्टेट एरर को बढ़ा देगा बाय वैल्यू के डी. व्हेन यू ब्रिंग ए पी प्लस डी कंट्रोलर, व्हाट हैपेंस? P प्लस डी कंट्रोलर स्टडी स्टेट एरर को के डी बढ़ाएगा और के पी से घटाएगा, ई एस एस प्लस के डी बाई के पी होगा, और जीटा को बाई रूट के पी करेगा, ओमेगा एन को रूट के पी करेगा. P डी पी डी। इस पे ही ज्यादातर क्वेश्चंस होते हैं, क्योंकि पीआई और पीआईडी जो होते हैं ना, दे विल इंक्रीज द ऑर्डर ऑफ द सिस्टम बाय वन, सेकंड ऑर्डर बिकम्स थर्ड ऑर्डर, एंड अगेन यू हैव टू एंटर इनटू द डोमिनेंट रूट कॉन्सेप्ट. सो क्वेश्चंस आर रेयर, बट दे डू. What integral controller does, it will make the steady state error zero. It will reduce the stability as well as accuracy, stability and speeds of the system. But steady state error zero बना सकता है. So if your intention is to make steady state error zero, it is integral controller. But because of the drawback of that with the stability, we go for PI controller. And PID will improve the complete response of the system. Questions will be rarest of the rare in that, because the order will be very high. Even if the question comes, it will be very easy to solve it. Easy type of questions होते हैं. मान लीजिए एक सेकंड ऑर्डर सिस्टम होगा, उसके साथ एक पीआईडी. यू माइट हैव सीन दैट इन द टेस्ट सीरीज. यू माइट हैव सीन माय सॉल्यूशंस आल्सो फॉर दैट, फॉर दोस क्वेश्चंस इन द टेस्ट सीरीज. एक सेकंड ऑर्डर सिस्टम विद ए पीआईडी कंट्रोलर, पोल्स हैव टू बी ऑन सो लोकेशन, फाइंड द वैल्यूज ऑफ केपी, केडी, केआई. इससे ज्यादा कोई डिफिकल्टी नहीं होगी. Designing of the controllers and compensators will, of course, will be an exclusive topic of mains exam, not of objective. एक simple question इस तरह का मैं यहाँ से आपको बता दूं. मान लीजिए एक सेकंड ऑर्डर सिस्टम है, 1/ss plus 1. इसको एक PD कंट्रोलर के थ्रू, with the help of a PD controller, we want to make zeta of the system to be 1 and say steady state error of the system to be 0.2. It means what is the existing zeta? Existing zeta of the system is 0.5. Existing steady state error type 1 है ना, रैंप इनपुट के लिए ही हो सकता है, it is 1. Existing steady state error 1, existing zeta 0.5. But we want the zeta to be 1, we want the steady state error to be 0.2 for the same input. So use a P plus D controller for that. Only P cannot meet these two conditions, क्योंकि proportional controller क्या करेगा, वो zeta को further decrease करेगा, रूट KP से divide कर देगा ना, लेकिन steady state error को भी decrease करेगा. यहाँ हमको steady state error को decrease करना है और zeta को increase करना है. डेरिवेटिव कंट्रोलर zeta और steady state error दोनों को increase करेगा. Proportional controller zeta और steady state error दोनों को decrease करेगा. zeta को increase करना है, लेकिन ESS को decrease करना है. Then you can strike that, strike balance between them with the help of a PD controller. So all that you need to do is design the value of KP and KD to meet this requirement. Don't have the analysis. Analysis तो क्लास में करते हैं. यहाँ तो भाई conclusion पे आ जाओ ना. What is it? See, zeta new will be zeta old plus KD omega n by 2 by root KP. ESS new will be equal to ESS old plus KD upon KP. That's simple. Straight away come to this. That's what my argument is. इसका पूरा analysis 10 मिनट 15 मिनट करके सीखा तो है क्लास में, wherever. But why do you do that analysis again in the question? When it comes to question, your answer has to be this. Do like this. Do like this, okay? बाबा ये सारा लाइव जाता YouTube में, तो सारी आवाजें रिकॉर्ड होती, बाद में कर ले सकते नहीं. Hello? Yeah, I'm sorry. I think voice break हो गया था. Let me just repeat about the previous question. Voice got disturbed. So let me just remind what I was telling. ये जो steady state error और जो zeta है ना, उसके direct formulas इस्तेमाल किया जाए. अभी जो मैंने बोर्ड पे लिखा था ना, I just have erased, but I'm providing the voice again. Whatever you missed just now. I said that don't do that analysis innovatively again. We did that. We have the conclusions. You just have to, use those end conclusions of zeta, ESS, or omega, and whatever in order to finish the matter. Substitute them and solve those unknowns. You will be done with it. So all these things should be there in your short notes so that just before the exam you will be able to revise. So let me, end this response analysis discussion with this. Let me move to few questions of stability, RH criteria, root locus, whatsoever. Consider open loop transfer function of a system to be ks plus 2 square upon s plus 1 square. Consider open loop transfer function to be this. Question is to find the condition for stability and condition for oscillations and frequency of oscillation. These model questions are very important. Finding the condition for stability, finding the condition for oscillations, and finding the frequency of oscillations. Very, very happening questions. We know how to do that. RH criteria, router, ये सारी कहानी आप जानते हैं. You will find the condition for stability of the system to be -1/4 less than k less than infinity, or -1 less than k less than minus infinity. You will get this to be the range of values of k for the system to be stable. ये मिलेगा आपको. We know how to get that. We are not new to this. ये है stability condition. Now the question is about oscillations condition. I want you to be very careful with this. Oscillator is marginally stable, but marginally stable system need not be oscillator. That marginally stable system is oscillator which is undamped. For k is equal to -1/4 system is marginally stable. For k is equals to -1 system is marginally stable. No doubt. Sir, is it oscillator? We can say that only if it is found to be undamped. So, these two are marginally stable conditions, no doubt, but whether they are oscillation condition or not, that we can get this clarity only when we come to know what is the undamped condition. How to get undamped condition? Undamped means zeta 0, and zeta happens to be the coefficient of S ka coefficient. That you will find in the Raut array in s power 1 row. So form Raut array and equate the s power 1 row of Raut array to 0, you will get k to be -1/2. In this question, you form Raut array and equate s power 1 row to 0, you will get k to be -1/2. K is equals to -1/4 is marginally stable but not undamped. K is equals to -1 is marginally stable but not undamped. Hence, they are just marginally stable, they are not oscillator. So if you ask me what is the condition for oscillations in this question, no condition of oscillation, and thereby no frequency of oscillation. Though we have got two marginal stability condition, there is no condition for oscillations. In contrast to this, I would like to explain this question. ये भी एक ओपन लूप ट्रांसफर फंक्शन है. आप इसका भी स्टेबिलिटी कंडीशन पता कीजिए. You will get the stability condition to be this. We don't have time to solve and show you all those things. You know that. ये है k is equal to 1/3 marginally stable, k is equal to 1 marginally stable. But this marginally stable system, is it undamped? Is it oscillator so that we can say to be is it undamped so that we can say to be oscillator? That we need to check from Raut array. So form Raut array and equate s power 1 row of Raut array to 0. From here you will get k to be 1 or 1/3. Means for k is equals to 1/3, it is marginally stable as well as undamped, so oscillator. For k is equal to 1, it is marginally stable as well as undamped. So it is oscillator. So these two are conditions of oscillations. If both are present in the options, it is MSQ. अगर दोनों हैं तो फिर ये तो MSQ हो गया फिर. What about frequency of oscillations? We will get that from S square rho of Rautare. We know that. You will get one frequency corresponding to this to be root 8, another frequency corresponding to this to be root 20. That's how to handle this question. One of the most happening type of the questions. Be attentive to that. So what is that you need to learn from this? Oscillator is marginally stable, but marginally stable need not be oscillator. For it to be oscillator, it should be undamped. That's all. Another tricky question. Open loop transfer function of a system is k s plus 3 upon s plus 8 square. See, this question came twice in the previous paper. Previous papers में दो बार आया है, लेकिन थोड़ा सा ट्विस्ट कर दिया स्टेटमेंट में. यू नीड टू बी अटेंटिव. एक बार क्वेश्चन आया था, ओपन लूप ट्रांसफर फंक्शन इज दिस, फाइंड द कंडीशन फॉर ऑसिलेशंस. लेट मी आंसर टू दिस क्वेश्चन. स्टेबिलिटी जो है ना इस सिस्टम का, इट इज स्टेबल फॉर दिस. सो k इज इक्वल्स टू -16. इट इज मार्जिनली स्टेबल. आप s पर वन रो को जीरो करेंगे, यू विल गेट k इक्वल टू -16. Undamped oscillator. Answer to the question is k is equals to -16 is the condition of oscillations, and the frequency of oscillations you will get it to be root 4 radian per second. This is one way of happened once. दूसरे साल में same function, open loop transfer function of a negative feedback system is this. बस ये एक चीज ऐड कर दिया उसने. एक बार सवाल आया था, ओपन लूप ट्रांसफर फंक्शन ऑफ ए सिस्टम इज दिस, फाइंड द कंडीशन एंड फ्रीक्वेंसी ऑफ ऑसिलेशंस. आंसर इज -16 एंड 4 रेडियन पर सेकंड फ्रीक्वेंसी. दोबारा यही सवाल ऐसे सवाल किया उसने, ओपन लूप ट्रांसफर फंक्शन इज दिस and the system has got negative feedback. Now you give me the stability, now you give me the oscillation conditions and oscillations frequency. Now answer is there is no such condition. नहीं है ऐसा कोई condition. Then what is sir k is equals to -16? Oh come on, k is open loop gain. Open loop gain is positive in a negative feedback closed loop system, and open loop gain is negative in a positive feedback closed loop system. अगर नेगेटिव फीडबैक रिस्ट्रिक्ट कर दिया क्वेश्चन में, तब तो फिर ये k पॉजिटिव ही होगा. तो फिर स्टेबिलिटी का जो कंडीशन है ना, वो तो 0 लेस दैन के लेस दैन इन्फिनिटी में आ जाएगा, क्योंकि नेगेटिव कैसे लोगे फिर, नेगेटिव फीडबैक हो तो. अब तो फिर कोई मार्जिनल स्टेबिलिटी कंडीशन या ऑसिलेशन अनडैम्प्ड है ही नहीं. नो ऑसिलेशंस कंडीशन. सो प्लीज बी केयरफुल. This system is oscillator with positive feedback. Open loop gain -16, negative open loop gain, positive feedback. When we are free to choose any feedback, then I say that in case of positive feedback, for k is equals to -16, it is oscillator with this frequency. But when we are restricted with the negative feedback, this particular system has no oscillations with the negative feedback, so I say no condition. Okay? That way. Take up the next question, and perhaps the last with RH criteria. We have done enough. Characteristic equation of a system is s to the power 4 plus s cube minus 3s square minus s plus 2 is equal to 0. Let us find how many roots of the system are in the left side, how many are on the j omega axis, how many are in the right side of s plane. Try. Yeah, you might have tried. See, we know that the system is unstable because there are sign changes in the characteristic equation itself, so straight away unstable system. Forming the route array to find how many roots are in which side of S plane. 1, 1, minus 3, minus 1, 2, minus 2, minus 3 plus 1, minus 2, 2, this is 0. S power 1 row becoming 0. That means that, see, whenever a row of route array becomes 0, we always try to think of roots are on the j omega axis, not necessary. But it is compulsory that the roots are symmetric with respect to origin. So s to the power 1 row 0 means 2 roots are symmetric to origin. Which 2 roots they are, you can obtain from this auxiliary polynomial, that is minus 2 s square plus 2. To complete the route array, we differentiate this auxiliary polynomial. तो ये minus 4 हो जाएगा और ये 2 हो जाएगा. We divide the route array into 2 parts. This part of the route array deals with the roots that are symmetric to origin, and this will deal with the roots which are not symmetric to origin. Out of 4, 2 roots are symmetric, the remaining 2 are asymmetric. So how to locate them? 2 roots are symmetric with one sign change. So one will be in the right side, the other will be in the left side. Among remaining 2, still one sign change. One of them will be in the right side, the other will be in the left side. So this is how the 2 roots are located. 2 left में है, 2 right में है, 0 roots on the j omega axis. So what you need to realize, for roots to be on the j omega axis, it is compulsory that a row has to be 0, but if a row is 0, it is not compulsory for the roots to be on the j omega axis, is what I want to stress. Because it is compulsory for them to be symmetric to origin. It is not compulsory for them to be on the j omega axis. May or may not be, depends on the situation. So enough with RH criteria. But the most happening model happens to be regarding the oscillations frequency. So please have a look into that. Let me now take a few questions of root locus. Again, the way of answering to them quickly, that is more important. We have got 14 properties of root locus, 14 properties of complementary root locus. While learning, we do make use of them to get the root locus. But while we solving the exam, like that's not the way we did in the workbook. That's not the way that I showed you in the test series. So in that online test series, the way that I have provided the solutions, they are very much important and should be very attentive to those things. Reason is, in class, while learning, we will not have that way of approaching to the question कि भाई सीधा सीधा आप आंसर पे आ जाएं, क्योंकि सारे प्रॉपर्टी पता होना ज़रूरी है. आपको ईएस का प्रीलिम्स देना है, मेंस देना है, पूरा सब्जेक्ट सीखना है. यू नीड टू नो एवरीथिंग. You need to know the subject to the 100% to the extent that I know. I have to teach everything. But when it comes to applying them, try to think of the most innovative way of approaching the questions. That comes by practice. पता होना सब कुछ ज़रूरी है. You should know everything, but you should not use everything. Right? So you as a teacher, as a student, we need to know all about the subject. But we should not use all of the subject. तो जैसे सीखते हैं ना कन्वेंशनल वे में या फिर जैसे प्लॉट करते हैं वैसे ही यूज़ करोगे. नहीं, एग्जाम में ना तो प्रैक्टिस करके ऐसे तरीके पे आना है कि यू हैव टू मेक यूज ऑफ द ऑप्शंस. कभी ऑप्शंस को एलिमिनेट करना सीख पाएँ, है ना, ऑप्शन से आंसर वेरीफाई करना सीख पाएँ. तो ऐसा नहीं है कि बस क्वेश्चन दिया उसका आंसर बना के ही देंगे. नहीं, ऑप्शंस पे बेस करके भी, एलिमिनेट करके, क्रॉस चेक करके, कंपेयर करके, ऑल द टैक्टिक्स यू हैव टू मेक यूज ऑफ. देन ओनली यू विल बी गुड एट डीलिंग इन द एग्जाम. तो let's have a few questions of root locus. देखिए, open loop transfer function of a system is k s plus 2 by 3 upon s square s plus 2. एक question. दूसरा question, k s plus 4 by 3 upon s square s plus 12. तीसरा question, k s plus 2 upon s square s plus 1. तीसरा क्वेश्चन. तीनों एक ही कैटेगरी के हैं ये. इसके जो ऑप्शंस है ना, ऑप्टेन और आइडेंटिफाई द रूट लोकस ऑफ द सिस्टम. ऑप्शन ए, ऑप्शन बी, ऑप्शन सी, Option D. These are the four options. Identify the correct root locus. तीन क्वेश्चन है, एक नहीं. I can finish off all three questions in hardly 1 minute. More than enough. Sir, how? No calculations, nothing, some nonsense. Pay attention, please. Be conceptual. K by S square. We know how does the root locus of the system looks like. It is on the j omega axis. तो क्वेश्चन को ना स्प्लिट करके समझने की कोशिश करें. To that a zero and a pole are added. Zero is dominant. जो रूट लोकस j omega axis पे है, due to a zero, they will be attracted immediately away from the j omega axis into the left side of S plane. तो फिर ये तो ऑप्शन हो ही नहीं सकता इसके लिए. आंसर हैज टू बी एनी ऑफ दिस थ्री. पे अटेंशन. क्या j omega axis को कट करेगा? डोंट गो फॉर RH क्राइटेरिया, जरूरी नहीं है. j omega axis को वो कट करेगा जो पहले से राइट साइड में है. तो जो राइट में है उसको लेफ्ट में खींचने के लिए विद ए जीरो j omega axis को काट के आएगा. जो पहले से ही लेफ्ट में है या फिर जो j omega axis पे है वो जीरो की वजह से इमीडिएटली लेफ्ट में मूव कर जाएगा. इट इज नॉट गोइंग टू इंटरसेक्ट द j omega axis. नो चांस. When there is chance, when it is in the right side of S plane, when you are dragging into the left side of S plane with a dominant zero, it is going to cut the j omega axis. Otherwise, what does it cut? No need to go for RH criteria. Now, which among these two? Pay attention. Zero dominant, pole भी dominant. जब pole और zero दोनों dominant है ना, then zero का effect इतना नहीं हो सकता कि इसको under damp से critically damped बना दे. Answer is this. Zero dominant. Branches are dragged away from the j omega axis into the left side of S plane. पोल ऑर्डिनरी, तो फिर ये तो नेग्लिजिबल है. इसका इफेक्ट इतना ज्यादा होगा ना कि इसको काफी लेफ्ट में खींच के ले आ जाएगा. इट फॉर्म्स ए क्रिटिकली डैम्ड पोर्शन एज वेल लाइक दिस. अनडैम्ड से अंडर डैम्ड क्रिटिकली डैम्ड बना लेगा, लाइक ओनली हैविंग ए जीरो. देखो इस सेकंड ऑर्डर सिस्टम में सिर्फ जीरो डालोगे ना तो रूट लोकस ऐसे होगा. जब पोल भी आएगा लेकिन वो ऑर्डिनरी रहेगा, डोमिनेंट नहीं, देन इसका रूट लोकस ऐसे ही दिखेगा. सिर्फ जीरो होना, जीरो हो के पोल भी है लेकिन पोल ऑर्डिनरी होना, दोनों एक बराबर हो जाएगा ऑलमोस्ट. तो फिर इसका रूट लोकस ऐसे लगेगा. ये तो सिर्फ जीरो वाला सिस्टम है. जीरो और पोल भी है लेकिन पोल ऑर्डिनरी, जीरो डोमिनेंट चाहिए. ये 0.6 इंटू 3, 0.66 इंटू 3 ऑर्डिनरी होने के लिए 5 टाइम्स या उससे ज्यादा अवे होना चाहिए. डोमिनेंट, ये भी डोमिनेंट, तो फिर ये तो हो ही नहीं सकता. आंसर इज दिस. जीरो कैलकुलेशंस कॉन्सेप्ट हो गया ना. हाँ सर, ये किसका हो सकता है? ये किसका? ये 1.3, ये 12, ऑलमोस्ट 9 टाइम्स इसका रूट लोकस है. ये इसके लिए रूट लोकस है. ये ना ये हो सकता, ये हो ही नहीं सकता, ये भी नहीं. सर वो किसके लिए होगा? इसका रूट लोकस है. ये वो कैसे? ये कौन? पोल डोमिनेंट. पोल इज डोमिनेंट. जीरो भी डोमिनेंट है लेकिन प्राइमरी कौन है? पोल. दिस इज क्लोज टू ऑरिजिन. तो k बाय एस स्क्वायर पे जब आप पोल को डोमिनेंट करोगे, जीरो को ऑर्डिनरी रखोगे, पोल इज गोइंग टू रिपल द रूट लोकस ब्रांचेस अवे फ्रॉम द j omega axis and away from it. I mean towards the j omega axis, away from it. Zero will attract the root locus branch away from the j omega axis towards it. Pole will repel the root locus branch away from it and towards the j omega axis. तो इसका है ये रूट लोकस बिकॉज ऑफ पोल डोमिनेंट. इसका ये रूट लोकस ये है. इसका रूट लोकस ये है. ये किसी का नहीं हो सकता. अमंग दिस किसी और का होगा जिसमें शायद ब्रांचेस पहले से राइट में है, फिर वो कट करके j omega axis को लेफ्ट में आए. So if you sincerely want to solve, you can solve, but will take your time. And you should solve. ये root locus बनता कैसे है, क्या करेंगे? You need to, make use of all these properties while learning. You have learned. You are at the application level now. Next, open loop transfer function of a system is k upon s, s plus 4, s square plus 4s plus 20. K upon s, s plus 4, s square plus 4s plus 5. K upon s, s plus 3, s square plus 3s plus 4.5. K upon s, s plus 3, s square plus 2s plus 2. All these questions happened in various exams, various times, various branches. सबका मोटो एक ही है. फाइंड हाउ मेनी नंबर ऑफ ब्रेकअवे पॉइंट्स द रूट लोकस ऑफ द सिस्टम हैज। सवाल क्या है, हाउ मेनी नंबर ऑफ ब्रेक अवे पॉइंट्स आर देयर इन द रूट लोकस ऑफ द सिस्टम, यह है सवाल। नंबर ऑफ ब्रेक अवे पॉइंट्स इन द रूट लोकस ऑफ द सिस्टम। सर वो तो बड़े मजे का काम है। breakaway points can be obtained from the solutions of dk by ds, है ना? That's where you have mistaken. Breakaway point are obtained from the solutions of dk by ds, but the solutions of dk by ds need not be breakaway point. For it to be breakaway point, it should be on the root locus. Further twist. Oscillator is marginally stable, but marginally stable need not be oscillator. For it to be oscillator, it should be undamped. Breakaway point is obtained from the solution of dk by ds, but dk by ds solution need not be breakaway point. For it to be breakaway point, it should be on the root locus. Got it? For roots to be on the j omega axis, a rho has to be 0. But if a rho is 0, the root need not be on the j omega axis. A rho is 0, and if the roots have to be on the j omega axis, then there should not be sign changes among the first column elements of route array. So many conditions. Learn things properly. Okay. सर कैसे करेंगे? पहले तो आपको डीके बाय डीएस सोल्यूशन बनाने पड़ेंगे। कैरेक्टरिस्टिक इक्वेशन बनाइए, डीके बाय डीएस बनाइए, क्यूबिक पॉलिनोमियल बनेगा। पहले उसके 3 रूट निकालिए। वो 3 रूट निकलने के बाद भी कोई भरोसा नहीं है कि वो ब्रेकअवे पॉइंट बने। फिर हर किसी को चेक करके देखना होगा कि वो रूट लोकस पे है या नहीं। अगर वो सोल्यूशंस ऑफ डीके बाय डीएस रियल निकल आए, देन इट्स वेरी इजी टू चेक वेदर दे आर इन द रूट लोकस आर नॉट यूजिंग वन ऑफ द प्रॉपर्टीज. Root locus exists at those points on the real axis to the right of which the total number of open loop pole plus 0 happens to be odd. But unfortunately, if those solutions of dk by ds comes out to be complex, your complexity has increased further. You have to make use of the phase condition. You need to check the phase of the open loop transfer function at that complex solution of dk by ds. If that becomes plus or minus 180 degree, then you have to accept, otherwise you have to reject. By the time you do all this, you will be out of the examination. भाई एक क्वेश्चन करोगे इस हाल का तो 5 मिनट या 10 मिनट लगा दोगे. Where is the scope for this question? तो फिर सर ऐसा क्वेश्चन ऑब्जेक्टिव एग्जाम में आया कैसे, और आएगा तो हम डील करेंगे कैसे? You need a bit of attention and better understanding of the concept. Pay attention. I mean, इस particular model के लिए बात करूं मैं, क्योंकि one of the most happening. We're here to discuss most happening questions, right? वरना questions तो infinite number है. Average of the real poles, real part of the complex poles, अगर बराबर है ना, तो 3 breakaway points होंगे. Average of the real pole, real part of the complex pole, बराबर होगा तो 3 breakaway point होंगे. Average of the real pole और real part of the complex pole अगर बराबर हुआ तो 3 breakaway point होंगे. Average of the real pole और real part of the complex pole बराबर नहीं हुआ तो एक ही breakaway point होगा, और एक होगा तो real ही होगा. एक बार सवाल आया था, देखिए इसके बारे में सवाल था, how many number of breakaway points are there. इसका सवाल था, the system has 1 real, 2 complex breakaway points, 3 real breakaway points, 1 real breakaway point, no breakaway point. ये 4 ऑप्शन थे. यानी it is not enough to know whether you have got 1 breakaway point or 3 breakaway points. You may also have to further elaborate if they are 3 breakaway points, are they real or real and complex, real or complex का combo. Pay attention. How can I convince you with that part? So, you know, it's like either 3 real or 1 real and 2 complex. ये हो सकता है ना, 3 में से 3 real or 1 real and 2 complex. 3 real, 1 real and 2 complex, ये combination. ये जो पोल है ना -2 प्लस आर माइनस J4, और ये जो पोल है -2 प्लस आर माइनस J1, ये जो पोल है -1.5 प्लस आर माइनस J1.5. Listen, if the imaginary part of the complex poles is more than that of the real part, then 1 real, 2 complex. If the imaginary part is less than that of that real part, then 3 real. If the imaginary part is equal to that of the real part, 3 real as well as equal. यहाँ 1 real, imaginary part is more than that of the real part, 1 real, 2 complex. Imaginary part is less than that of that real part, 3 real, but unequal. Real होंगे, unequal रहेंगे. Imaginary part, real part एक बराबर हो गया, 3 real हो जाएंगे, equal हो जाएंगे. दैट्स अ सिंपल थिंग. इसके बेस पे ना इनका रूट लोकस को आइडेंटिफाई करना भी बड़ा आसान. सर, वी आर आस्क्ड टू आइडेंटिफाई द रूट लोकस ऑफ दिस सिस्टम. हाउ टू चेक दैट? You got the information about the breakaway points now. That's the crucial thing. इसका जो रूट लोकस होगा ना, one real, two complex with the same real part रहेगा वो. This is how the root locus looks like of this system. For this, I said three real and unequal. You need to handle the breakaway points such that you get multiple branches over there. Here, I said three real and equal. तीन है, तीनों equal है, तो सब वहीं आएंगे. Then they will go to infinity along asymptotes. In this, I said only one real. Somewhere here will be the breakaway point. So these two will go to infinity along asymptotes. These two will meet at some point here, and they also go to infinity along asymptotes. Very easy to understand. Root locus is very, very easy topic, provided if you have enough understanding and enough practice. Getting that? Now, let's take just a few more questions. Give me a second. See this. Open loop transfer function of a system is 10k upon s plus 1 s plus 2. Open loop transfer function of a system is 10k upon s plus 1 s plus 2. Question is to find the value of k at the point at which all the root locus branches are going to meet. Hope I have dictated the question. That should be enough. Question is to find the value of k at the point at which all the root locus branches meet. I'm sorry. The pole is at -1. One pole is at -1. The other pole is at -2. If we obtain the root locus of the system, it will look like this. The point at which these two root locus branches meet, known as breakaway point, which can be obtained from the solutions of dk by ds, and that becomes -1.5. What I would like to add here, there is a property which says that the value of the open loop gain at any point on the root locus is given by product of length of the phasors drawn from all the open loop poles to that point upon product of length of the phasors drawn from all the open loop zeros to that point, right? So, according to that property, you know what has to be the value of k here. What is the product of this phasor? Oh, sorry, what is the length of this phasor? 0.5. What is the length of this phasor? Obviously 0.5. So, product of them 0.25. ये 0.5, ये 0.5. Product 0.25. Fine. So, answer to the question has to be 0.25. Suppose if I try this question using magnitude condition, या फिर characteristic equation से भी कर सकते हैं, अलग अलग तरीके हैं ना. s square plus 3s plus 2 plus 10k is equal to 0. You can substitute s is equal to -1.5. You can get k from here. Suppose if I substitute, what I get? S square 2.25 minus 4.5 5 plus 2 plus 10k is equal to 0. How much this will be? It is 2 plus 2.5 is 4.5 minus this. So 10k is equal to 0.25. The value of k that I get is 0.025 is what I would like to stress here. We are getting it to be 0.25, but here we are getting it to be 0.025. Characteristic equation के method से. Suppose if I use magnitude condition. What is magnitude condition? I know that this point is on the root locus, then the magnitude of this open loop transfer function, it has to be 1. From this, I will get k to be 0.025. This method, that method, giving me k to be 0.025. Whereas, this method is getting me 0.25. Both are not same. Where is the mistake? Please understand this property very clearly. Most of us, we take it as an outlook of it. We don't understand the inner meaning of it. The value of the open loop gain at a point on the root locus is given by so and so. What is open loop gain? Open loop gain of the system is not k, it is 10k. So property जो है ना open loop gain की बात करेगा. You have to be very careful. Root locus properties are framed for open loop gain. You should be very careful. They are not framed for k. If open loop gain is k, then the properties are for k. If the open loop gain is 10k, then the properties are for 10k. क्योंकि आप k से 10 को जुदा तो नहीं कर सकते हो. तो open loop gain 10k है. तो the mistake that people may do is here. तो सीधा सीधा k का वैल्यू निकालने की कोशिश करेंगे, नहीं निकलेगा. अगर ओपन लूप गेन k है तो k का वैल्यू निकलेगा. अगर ओपन लूप गेन 10k है ना, तो भाई आप जो सॉल्व कर रहे हैं वो 10k का वैल्यू है, तो वहां से k आप अलग से फिर दोबारा सॉल्व कर लीजिए. 0.025. इट्स अ क्वेश्चन इन द गेट एग्जाम. बी केयरफुल. डन विद इट. Next, open loop transfer function of a system is k s plus 1 upon s square s plus alpha. Open loop transfer function of a system is k s plus 1 upon s square s plus alpha. Question is, find the value of k at the point at which all the root locus branches meet. I repeat, find the value of k at the point at which all the root locus branches meet. Just like the previous question, function is different. अब सवाल ये उठता है कि सर we are asked to find the value of k at the point at which all the root locus branches meet. यहाँ open loop gain भी k ही है, तो सीधा तो k का वैल्यू निकाल सकते हैं. बिल्कुल. First you need to know that point. How do we find that point? As the solutions of dk by ds. dk by ds. But you cannot find the solution of dk by ds because you have another unknown alpha. So k is minus s square s plus alpha upon s plus 1. How do you do dk by ds? Not possible. Several students get stuck here. Usually they ask me that out here. Of course, I gave you the answer. I give you another way of doing it. You will not be able to get the solutions of dk by ds. You should have only one unknown, that is k. All others should be known. Alpha का value नहीं दे रखा. Alpha will be constant. Alpha should be constant. But what is its value? It is not given. Then how can I assume? So then, sir, what to do? This way you cannot proceed to this question. What is the question says? All the three root locus branches of the system are going to meet at some point, is what is mentioned. Let that point be minus x. So at that point, they all are equal. The characteristic equation of the system at that point will become s plus x का क्यूब. तो ये अप्रोच से तो नहीं कर पाओगे आप, जैसे प्रीवियसली किया था. Characteristic equation of the system becomes s cube 3s square x 3s x square plus x cube is equal to 0. Whereas the original characteristic equation is s cube s square into alpha plus ks plus k is equal to 0. Compare them. So what do you get? Alpha is equal to 3x. K is plus k. Okay. Alpha is equals to 3x and k is equal to x cube, or k is equal to 3x square. So x becomes 3, alpha becomes 9, or k becomes 27. That's it. So this point is minus 9. No, I'm sorry. Alpha is minus 9. Alpha. Question, we have to find k, right? Yeah. So we don't have to find alpha, but I got it. Alpha is minus 9, and this point x, what is x? 3. So this is minus 3, 0, and the value of k here is 27. You can verify that with the length of the phasors. From here the distance is 3. K is equal to 3 into 3 x is 3, right? X square, x is equal to 3. Yes. Alpha is 9. Fine. So the question is to find the value of k. I mean, when there is unknown in the transfer function, the question is to find the point at which the root locus branches meet and the value of k at that point. So you can go by this dominant root concept है नहीं ये. We are considering all the roots to be equal there. So s plus x का cube हो गया. वहाँ से हम solve कर पा रहे हैं कि k 27 आ रहा है, and x is becoming 3, and k at that point that is becoming 27, and the point alpha is 3 into 3, 9. The alpha value is this 9. What I was trying to convince you with, x0 भी तो है, you missed that. 0 is minus 1. That's what. Now you can try the value of k using that property. अभी जैसे पहले solve किया था, उसे आप try कर सकते हैं. Length of this phasor 3 into 3. Length of this phasor, it is 6 upon 0 से जो लेंथ आएगा ना वो 2. This is 27. The same thing. See this. ये 0 minus 1 के पास है, ये pole minus 9. Ordinary हो गया ना. That's why the branches are meeting. I have explained in one of the questions of the root locus earlier. That way. Next. Open loop transfer function of a system is k upon s plus 2 ka square. Calculations part we are least bothered about. Let's focus on the concept. Root locus will intersect. Root locus intersects zeta is equal to 0.5 line. Find k at that point. Find k at that point. ये है सवाल. इस सिस्टम का जो रूट लोकस है ना वो zeta is equals to 0.5 लाइन को कट करेगा किसी पॉइंट के पास. वहां पर k पता करनी है. If you want to find the k at any point on the root locus, you should know that point. Point coordinates are most important. If you want to find the value of k at any point on the root locus using any approach, you should know that point. And that point is not mentioned. You are asked to find the value of k at that point. Zeta is equals to 0.5. Under a damped. A point of under a damped system, that point of under a damped system will definitely be minus alpha plus or minus j omega d. है ना? Zeta 0.5 मतलब under damped. Under damped का point तो यही होगा. So I can generalize that point to be minus alpha plus or minus j omega d, but I have to find it in specific. So that point we can write it to be minus zeta omega n comma omega n root 1 minus zeta square. We know zeta 0.5. We know one of the coordinates of this point which is zeta. We don't know the other coordinate of that point which is omega n. Zeta और omega n दोनों मिलके coordinates form करेंगे. एक तो पता है दूसरा नहीं पता. How to find this omega n? You cannot do it from here क्योंकि k तो unknown है. If I know k, then I can find omega n from there. We are totally stuck. सर अब कैसे करें? पॉइंट के बगैर k नहीं पता करेंगे और पॉइंट के लिए ओमेगा n चाहिए. ओमेगा n फिर ये k के बगैर नहीं पता हो सकता है. Then how to do with that? Very simple. Phase condition. Phase condition के दो काम हैं. Phase condition will help you not only to find whether a point of S-plane is on the root locus or not. It also helps you to check. It also helps you to find the missing coordinate of the point. Phase condition can be used to check that a point of S-plane is on the root locus or not. It can also be used to check, or it can also be used to find a missing coordinate of that point. तो अब फेस कंडीशन को हम पॉइंट चेक करने के लिए इस्तेमाल नहीं कर रहे हैं. हमको पता है कि पॉइंट रूट लोकस पे है, फिर क्यों चेक करेंगे? लेकिन हमको पता है कि एक पॉइंट रूट लोकस पे है लेकिन उसका एक कोऑर्डिनेट मिसिंग है. उसको पता करने के लिए भी फेस कंडीशन इस्तेमाल हो सकता है. इज व्हाट आई वांट यू टू फोकस ऑन. सो फेज ऑफ k अपॉन s प्लस 2 स्क्वायर. सर व्हाई नॉट मैग्नीट्यूड कंडीशन? बिकॉज मैग्नीट्यूड कंडीशन में k पार्टिसिपेट करेगा एंड k इज स्टिल अननोन. फेस कंडीशन में k तो काम ही नहीं करेगा. तो फेस ऑफ दिस फंक्शन एट s इज इक्वल्स टू माइनस जीटा ओमेगा n plus j omega n root 1 minus zeta square should be 180 degree where zeta is already known to be 0.5. तो यहाँ आप सॉल्व कर लीजिए ना. ओमेगा n you'll get it to be 1. तो फिर एक बार ओमेगा n मिल गया ना तो फिर आप वहां से k पता कर ही सकते हैं. So you know this point and then you can use magnitude condition. So got it? Using phase condition, I will set the missing coordinate of that point. Once I get that point, I will use magnitude condition to find the value of k at that point. I'm done with the question. Fine. Just one or two more questions. With that, we will be done with the root locus as well. See, transfer function, that is closed loop transfer function of a system is k upon s square 3 minus k into s plus 1 equation hai. Here, you have to find root locus. What most of the people try to do, sir, to do root locus or to get complement to root locus, we need open loop transfer function and we have closed loop transfer function. We subtract the numerator from the denominator, we get it. That's where the mistake you may do. Pay attention. This k is closed loop gain. This k is open loop gain. Both are denoted with the same notation. So don't try to interface the closed loop gain with the open loop gain. That's a stupid thing that you can ever do. So that approach here not applicable, where both are made to be as parameters. Then sir, what to do? भाई ये characteristic equation है. Write it to be 1 plus gh is equals to 0. So you will get open loop transfer function to be minus k s plus 1 upon s square plus 3s plus 1 या 3s plus ऐसा कुछ आएगा. ये complex poles and zeros लिखिए देते हैं. s square plus 3s plus 3 minus ks minus k is equal to 0. So minus k into s square plus 3s plus 3 आएगा ये. That's all. So this is the open loop transfer function. Because of minus k, you need to end up with complementary or inverse root locus, right? One last question. Root locus of a system is given. Find closed loop transfer function. पहले तो ओपन लूप ट्रांसफर फंक्शन बना लीजिए. k बाई s प्लस 1 s प्लस 2, बड़ा आसान है. दिस इज ओपन लूप. व्हाट विल बी क्लोज लूप ट्रांसफर फंक्शन? g बाई 1 प्लस gh, कंसिडरिंग फीडबैक टू बी यूनिटी बाय डिफॉल्ट. ये g है, ये ओपन लूप ट्रांसफर फंक्शन है, तो ये खुद ही g है इफ h इज 1. डन. दिस इज व्हाट इज द क्लोज लूप ट्रांसफर फंक्शन. Pay attention. Locus is not root locus, it is CRLD. Sir, कैसे? It is passing through those points on the real axis. To the right of is the total number of open loop pole plus 0 happens to be even. ये CRLD है और CRLD is for a positive feedback closed loop system. In positive feedback closed loop system, open loop gain is negative. For God's sake, this is open loop gain. दिस बिकम्स क्लोज लूप गेन, डोंट मेस अप, इसको नेगेटिव बनाओ, उसको नेगेटिव ना बनाओ. CRLD for positive feedback closed loop system. In positive feedback closed loop system, open loop gain is negative. Open loop gain ये है, वो नहीं, just like the previous question. So answer to the closed loop transfer function of the system is k upon s plus 1 s plus 2 minus k, that way, right? So these are few questions about root locus. Now we move to frequency domain. So let's continue with the frequency response discussion. We had a few questions of time domain so far. See, remember, though there may not be a question, frequency domain, why it is superior in what way to that of time domain? Frequency domain analysis is easy, accurate and flexible, and moreover certain new characteristics which cannot be seen in time domain can be seen in frequency domain. One of the best options is, it's about gain margin, phase margin. Gain margin can be determined both in time domain and frequency domain, but phase margin is the only frequency domain concept. There are many issues with the gain margin, many limitations. If you fail to deal the analysis of the system through gain margin, then there is an alternate for phase margin which is in frequency domain. If you want to talk about bandwidth, it is possible only in frequency domain. And system with the transportation delay is can be handled accurately only in frequency domain. In time domain, it is an approximate one. Correct? In frequency domain, we obtain the transfer function using Fourier transform, and that is a complex function, so we deal with the magnitude and phase. So simple definition of frequency response analysis is magnitude and phase response analysis. We have got all those frequency response parameters and questions based on them. So all those restrictions are again imposed. Only if it is standard second order, then use those formulas of 100 amp. Otherwise, you need to derive them from the response expression. This care you have to take. The questions on response parameters are very easy and simple. Let me focus more into the polar, Nyquist board, gain margin, phase margin into them. See, regarding obtaining polar plot, I gave you an excellent way of finding the polar plot. For strictly proper minimum phase, you can directly conclude about the magnitude and phase. See, this shape of the polar plot should not be a point of discussion. इसपे बहस ना हो, क्योंकि we are not here to design any jewelry. We are not jewelry designers. That we are making to be a very artful and artistic manner. इसका curve ऐसा निकालो, वैसा shape दो, ऐसा इसका ढांचा बनाओ भाई. Are we designing a jewelry that we think of the shape of the polar plot and the Nyquist plot or the board plot or even the root locus plot? We never ever talk about the exact shape of it. We are just bothered about the most appropriate or the approximate shape of it because our interest is in the system analysis. But sometimes what happens, some people try to be very particular with the shape of the polar plot in the options given. Then of course we have to focus, because as a matter of question I need to answer. I mean to say this. मान लीजिए open loop transfer function of a system is k upon s, s plus 1, s plus 2. Open loop transfer function of a system is this. We know that its magnitude varies from infinity to 0 because type 1 strictly proper, and its phase varies from minus 90 degree to minus 270 degree, isn't it? Magnitude varies from infinity to 0. Phase, it varies from minus 90 to minus 270. Now, इसका जो polar plot है ना, I used to draw like this. This is how I draw its polar plot. Sir, options में मान लीजिए एक polar plot ये है, एक shape. दूसरा शेप ये है, थर्ड इज दिस, फोर्थ समथिंग एल्स. मान लीजिए कुछ भी नाम दबाव या कुछ भी ले लीजिए. तीन पॉसिबिलिटी. सर तीनों में सर minus 90 to minus 270, मैग्नीट्यूड infinity to 0, तीनों ही जा रहे हैं. For this I know that this is a data which I can get directly. Let's go by the direct methods which we are using. We have solved plenty of the questions. I think at least 20 to 25 questions we have solved in the class if you are there in the polar plot itself, and a good number of questions in the Nyquist as well. But बहस क्या होना क्या कहती कि सर ये ऑप्शंस है. पहले तो मैं तो कहता हूँ कि फालतू का बहस है कि शेप ऑफ द पोलर प्लॉट इसको ऐसे ड्रॉ करें, ऐसे ड्रॉ करें, ऐसे ड्रॉ करें. ऐसा कोई सवाल पहले तो बनाना ही चाहिए, क्योंकि शेप ऑफ द पोलर प्लॉट से क्या करोगे, जो स्टेबिलिटी इससे है वो स्टेबिलिटी इससे भी है, वो स्टेबिलिटी इससे भी है. आई मीन टू से let this intercept be, for example, minus 0.1. The intercept made up of the polar plot of this system, minus 0.1. Say for k is equal to 1. Assume. I don't know how much it exactly. We don't know. This is some A, this is B, whatever it be. So, ये intercept मान लीजिए minus 0.1. Then minus 1 is here. Minus 1 is here. Minus 1 is here. Stable. तीनों से तो एक ही जवाब मिलेगा. Stable ही तो मिलेगा. तो फिर shape of the polar plot से क्या बहस हो गया बताइए? Why we are talking about the shape of the polar plot and why you are arguing on that? We obtain polar plot in order to determine the stability of the system. Whether I draw the polar plot of the system in any of these three cases, the stability come out to be the same. ऐसा नहीं कि सर यहाँ से तो stable दिख रहा है, यहाँ से unstable दिख रहा है, वहाँ से marginally stable दिख रहा है, चलो कुछ बात बनेगी. जब तीनों में एक ही है तो कैसे ड्रॉ करूँ, क्या फर्क पड़ने वाला है? Ultimately, our curiosity is about the stability of the system. लेकिन मान लीजिए अगर किसी एग्जामिनर को कुछ और सवाल नहीं मिला, उसने शेप ऑफ द पोलर प्लॉट पे ही बहस करने के लिए सवाल बना दिया. लेट्स आंसर टू द क्वेश्चन. सर, व्हाट इज द डिफरेंस बिटवीन दीज थ्री? पे अटेंशन. Here frequency is omega is equals to 0. Here frequency is omega pc. We know phase crossover frequency. Project this onto the x-axis. What is this? The real part of the magnitude of this system at omega is equals to 0 is this, and this is the real part of the magnitude at omega pc. This is the real part of the magnitude of the system at omega is equal to 0, and this is the magnitude, real part of the magnitude of the system at omega pc, where phase is minus 180. Projected just like that, projected like that. Those two magnitudes are given to be equal. Here in this plot it says that the real part of the magnitude at omega is equals to 0 is absolute value, अगर magnitude की बात करूं, is greater than that of the real part of the magnitude at omega pc. Negative sign हटा के बात करो. This is small, this is large. This value is large, this value is small. They are equal. Here what is the difference? At omega is equals to 0, the real part of the magnitude is smaller than that of the real part of the magnitude at omega pc. Omega pc तो ये phase crossover frequency. ये है फर्क. Got it? So in this question it is mentioned that the real part of the magnitude at omega is equals to 0 is larger than that of the real part of the magnitude at omega pc. In this question in this option it is mentioned that the real part of the magnitude at omega is equals to 0 and real part of the magnitude at omega pc both are equal. In this question it is shown that the real part of the magnitude at omega is equals to 0 is smaller than that of the real part of the magnitude at omega pc. तो ये बहस है. हालांकि स्टेबिलिटी तो तीनों के सेम है. तो if such thing comes, then you can find omega pc by equating the phase to minus 180. In this standard third order system, omega pc becomes 1 by root t1 t2, where t1 is the time constant of this pole, t2 is the time constant of this pole. And time constant form में that intercept at omega pc becomes k t1 t2 upon t1 plus t2. We all know this. It's all there in our discussions. So what you can do, you can find this intercept by equating the phase of the system to minus 180. चार तरीके हैं पूरे. There are four methods. You can go by RH criteria, you can go by rationalization method, or you can go by equating the phase of the system to minus 180 degree, or you can form the characteristic equation and you can pick the odd terms and then you can equate it to 0. चार method हैं. It's up to you. एक और method भी है, but that's applicable very limitedly. Let me finish with that part. You can find that intercept. So how to find this part? Rationalize the transfer function, separate that into real and imaginary part. In the real part of the transfer function, you put omega is equals to 0. You will get this. Transfer function को rationalize कर लेना, rationalization method इस्तेमाल कर लेना, दोनों काम हो जाएंगे. Rationalize the transfer function, separate that into real and imaginary part. In real part, you put omega is equals to 0, you will get this value. And you equate imaginary part to 0, you will get this frequency. That frequency you again substitute in the real part, you will get this part. You see which is large, which is small, and you choose your option. That way you will be able to answer to this question. But I say that कि पोलर प्लॉट के शेप पे तो बहस ना करें तो ज़्यादा बेहतर है, क्योंकि जब बात स्टेबिलिटी की हो तो फिर there was a doubt that one of the students was asking, sir, how does the polar plot of a zero looks like? क्योंकि सर आपने पोल के बारे में बताया, you taught so many polar plots. You taught how does the polar plot of a pole looks like. You taught how does the polar plot of two poles looks like, about pole at origin, minimum, non-minimum. You taught how does the polar plot of a zero and a pole wala system looks like. We have all this. We have never discussed just a zero. Reason, यार वो improper है. बात तो उसकी करे जो कोई practical हो, कोई meaning हो. Our system is mostly strictly proper. Very few cases proper. Our system is never improper. Improper. खत्म हो गई बात. ऐसी चीज की बात भी करके क्या फायदा जो होगा ही नहीं. Some people talk about negative damping. मजाक है. Why you are talking about negative damping, you tell me? Do you ever see anywhere in the practice? It's going to result into growing oscillations. If you don't damp, तभी system बर्बाद है. If you don't damp, undamped system, वो वैसे ही बर्बाद है sustained oscillation से. You have to damp so that you suppress those oscillations. Negative damping will और oscillations को भड़काएंगे. हाँ, हम ऑसिलेशंस को बुझाने की कोशिश करेंगे, हम ऑसिलेशंस को भड़काएंगे नहीं. लेट अस नॉट टॉक अबाउट नेगेटिव डैम्पिंग इवन इन थ्योरी. प्रैक्टिस थ्योरी में भी बात नहीं करेंगे, क्योंकि कभी ना कोई सवाल है ना कोई क्वेश्चन बनाए नेगेटिव डैम्पिंग पे. नेवर. नेगेटिव डैम्पिंग के बारे में वी नेवर टॉक अबाउट. वी ऑलवेज टॉक अबाउट पॉजिटिव डैम्पिंग. वी डोंट टॉक अबाउट अनडैम्पिंग एज वेल. हाँ, मार्जिनली स्टेबिलिटी के केस में केस हो जाता है तो वी टॉक अबाउट. अदरवाइज वी ऑलवेज टॉक अबाउट पॉजिटिव डैम्पिंग सिस्टम. उसमें भी वी ऑलवेज टॉक अबाउट अंडरडैम्प्ड सिस्टम. वी हैव आवर ओन रीजंस. सिमिलरली वी डोंट टॉक अबाउट इम्प्रॉपर सिस्टम्स. रूट लोकस के सारे प्रॉपर्टीज हम मोर नंबर ऑफ पोल्स दैन नंबर ऑफ जीरोस, पी ग्रेटर दैन जेड, पी ग्रेटर दैन जेड, पी ग्रेटर दैन जेड, ये लेके बनाते हैं. तो आवर सिस्टम इज पी ग्रेटर दैन जेड सिस्टम, स्ट्रिक्टली प्रॉपर. रेयरेस्ट ऑफ द रेयर केसेस पी इज इक्वल टू जेड. जेड ग्रेटर दैन भी प्रैक्टिकल होता ही नहीं, थ्योरी में बात भी नहीं करेंगे. बहुत सारे रिस्ट्रिक्शंस है. देखो टाइप भी जो है ना, द मैक्सिमम टाइप दैट वी कैन डिस्कस इज टाइप 3. टाइप 3 के बाद टाइप 4 हो, टाइप 5 हो, भाई होगा ही नहीं ना थ्योरी में ना प्रैक्टिस में. रीजन, the intention of having type in the open loop transfer function of a system is to reduce the steady state error to 0. Type 3 system can make the steady state error 0 for step ramp parabola. सबका steady state 0 कर सकता है. तो उससे ज़्यादा टाइप की क्या ज़रूरत है, क्योंकि जितना ज़्यादा टाइप होगा उतनी ज़्यादा परेशानी होगी स्टेबिलिटी में. So type 3 is the maximum. Beyond that, no theory, no practice. Minimum phase system is what we take in practice, and that's what we discuss mostly in theory. और थोड़े नॉन मिनिमम फेज सिस्टम भी डिस्कस कर रहे थे क्वेश्चन के हद तक. लेकिन इम्प्रॉपर सिस्टम्स जो होते हैं ना, उनका डिस्कशन है. अगर फिर भी कोई बात कर दें, सर व्हाट टू डू, नो प्रॉब्लम. फेज इट वेरीज फ्रॉम 0 डिग्री टू प्लस 90 डिग्री. है ना अपने शॉर्टकट्स. मिनिमम फेज तो है, लेकिन मैग्नीट्यूड को डायरेक्टली सॉल्व ना करें, क्योंकि ये स्ट्रिक्टली प्रॉपर नहीं है. मैग्नीट्यूड वाला शॉर्टकट आई टोल्ड यू ओनली फॉर स्ट्रिक्टली प्रॉपर, व्हाटएवर वी नो. तो व्हाट अबाउट मैग्नीट्यूड, इट वेरीज फ्रॉम सम वैल्यू फाइनाइट, आई से के फाइनाइट टू इनफाइनाइट. अब इसको ड्रॉ करने के, मान लीजिए इसमें भी, इसके शेप पे भी बहुत सारे कुछ बहस होते हैं कि एक तरह का पोलर प्लॉट ये ड्रॉ करते हैं लोग, 0 डिग्री प्लस 90 डिग्री, और बी 0 डिग्री प्लस 90 डिग्री, 0 डिग्री प्लस 90 डिग्री, ऐसा कुछ, डी समथिंग नन ऑफ द अबव, ऐसा ऑप्शन ले लीजिए. सेम एक्सप्लेनेशन. यार पोलर प्लॉट के शेप के बारे में क्या बहस करें हम. We are not here to design the shape of the polar plot. We are here to obtain some rough polar plot and determine the stability of the system. Whatever stability that you determine from this polar plot, the same you will determine from here, the same you determine from here. So what is the difference? हाँ, अगर ऐसा कोई सवाल बन जाए, options आ जाए, then of course we have to discuss. Then sir, what is the difference? Similar to that of previous expression. At omega is equal to infinity, the magnitude that is k. यहाँ देखिए ओमेगा इज इक्वल्स टू इन्फिनिटी पे रियल पार्ट ऑफ द जो मैग्नीट्यूड है ना, वो ओमेगा इज इक्वल टू 0 है. यहाँ पर ओमेगा इज इक्वल्स टू 0 बिकॉज वी ऑब्टेन द पोलर प्लॉट फॉर ओमेगा वेरिड फ्रॉम 0 टू इन्फिनिटी. सो दिस पोलर प्लॉट सेज दैट ओमेगा इज इक्वल्स टू 0, ओमेगा इज इक्वल्स टू इन्फिनिटी, मैग्नीट्यूड इज सेम, रियल पार्ट ऑफ द मैग्नीट्यूड. दिस पोलर प्लॉट सेज दैट the real part of the magnitude at omega is equals to infinity is less than that of the real part of the magnitude at omega is equal to 0. This polar plot says that the real part of the magnitude at omega is equals to infinity is greater than that of the real part of the magnitude at omega is equal to 0. बस आप फैसला कर लीजिए कि कौन सही है कौन गलत है. तो आप इसका रिप्लेस एस विद जे ओमेगा प्लस जेड कर लेना. दिस इज रियल पार्ट, इसका मैग्नीट्यूड जेड या जो भी है के को मैं z कहता हूं. दिस इज z फाइनाइट, k इज इक्वल्स टू z फॉर मी. तो आप देख लेना कि ओमेगा इज इक्वल्स टू 0, दिस इज इंडिपेंडेंट ऑफ ओमेगा. ओमेगा इज इक्वल्स टू 0 पे, ओमेगा इज इक्वल्स टू इन्फिनिटी पे, दोनों पे मैग्नीट्यूड का रियल पार्ट तो z ही है, यानी k ही है. तो अब तो फिर ये हो जाएगा. If at all, if any such question comes like this. And we have discussed कि एक जीरो एक पोल होगा. Then how does the polar plot looks like? That's what is lead and lag compensators. We know. And some of this doubt that that I have received while answering to the questions in that EC and electrical group of Telegram, I wish to take up that as a part of discussion here so that everybody gets benefited. सर एक ओपन लूप ट्रांसफर फंक्शन, एक जीरो एक पोल का तो पता है, दो जीरो दो पोल है, देन सर व्हाट टू डू? मान लीजिए एक जीरो है, एक पोल है, and if the zero is dominant primarily, then this is the polar plot. Zero dominant है, पोल भी dominant है, लेकिन zero is close to origin, pole is less than 5 times, then this is the polar plot. मैं एक पोल जीरो की बात करूं. अगर zero dominant है, पोल ordinary है, then the polar plot will shoot like this. एक जीरो है, एक पोल है, पोल डोमिनेंट है प्राइमरीली, जीरो भी डोमिनेंट है, देन दिस इज हाउ द पोलर प्लॉट लुक्स लाइक. पोल डोमिनेंट है लेकिन जीरो ऑर्डिनरी है, देन दिस इज हाउ द पोलर प्लॉट लुक्स लाइक. सर दो जीरो है, दो पोल है. अब यहां मल्टीपल केसेस हो सकते हैं. मान लीजिए दोनों जीरो डोमिनेंट और दोनों पोल ऑर्डिनरी, दोनों पोल डोमिनेंट, दोनों जीरो ऑर्डिनरी, जीरो डोमिनेंट एक, दूसरा जीरो नहीं, बाकी पोल्स डोमिनेंट. इट लुक्स लाइक दिस. लेट मी ड्रॉ लाइक दिस. दिस इज फॉर द केस ऑफ जीरो जीरो पोल पोल. दिस इज फॉर द केस ऑफ पोल पोल जीरो जीरो. दिस इज फॉर द केस ऑफ जीरो पोल पोल जीरो. दिस इज व्हाट इज लीड लैग कंपनसेटर. ये लीड है, ये लैग है, ये लीड लैग है. ये जो है ना लैग लीड, पोल जीरो जीरो पोल, दोनों जीरो डोमिनेंट, दोनों पोल डोमिनेंट, एक जीरो डोमिनेंट और एक पोल डोमिनेंट. ये डॉटेड वाला, डॉटेड वाला एक पोल डोमिनेंट, ये दोनों पोल डोमिनेंट, ये एक जीरो डोमिनेंट, ये दोनों जीरो डोमिनेंट. सिर्फ एक जीरो एक पोल, दोनों डोमिनेंट, जीरो ही डोमिनेंट है, पोल ऑर्डिनरी. एक जीरो एक पोल, दोनों डोमिनेंट, सिर्फ पोल ही डोमिनेंट. मेनी केसेस. See this. Polar plot of a system is given. Polar plot of a system is given. Open loop system का ही तो होता है. The open loop system is option A, type 0 open loop, closed loop. Closed loop system stable. Option B, open loop type 1, closed loop stable. Type 0 closed loop unstable, type 1 closed loop unstable. Polar plot of a system is given. The question is, the question is ओपन लूप का टाइप क्या होगा और क्लोज लूप की स्टेबिलिटी क्या होगी. दोनों है इस क्वेश्चन में. ओपन लूप का टाइप क्या होगा, जीरो होगा या वन होगा, और क्लोज लूप की स्टेबिलिटी क्या होगी, स्टेबल होगा या अनस्टेबल होगा. वेयर इज -1? इट इज लाइंग ऑन टू द राइट साइड ऑफ द पोलर प्लॉट सब्जेक्ट टू द डायरेक्शन ऑफ द एरो. क्लोज लूप सिस्टम इज अनस्टेबल. ये तो बिल्कुल क्लियर हो गया. -1 coming to the right side of the polar plot. Closed loop unstable. Damn sure. Answer has to be either C or D. Cannot be A or B. अब टाइप 0 होगा या 1 होगा. सर ये कैसे बात करें? देखिए टाइप 0 है ना. I told you that when we vary omega from 0 to infinity, phase starts with -90 degree into type. -90 degree into type. अगर टाइप 0 है तो फिर 0 डिग्री से स्टार्ट होना चाहिए, टाइप 1 है तो फिर -90 डिग्री होना चाहिए। दिस इज 0 डिग्री, दिस इज -90 डिग्री, दिस इज -180 डिग्री, दिस इज -270 डिग्री, फिर से स्टार्टिंग अलॉन्ग -270 डिग्री एक्सिस। सर ये तो कॉन्ट्राडिक्ट कर रहे हैं, कोई ऑप्शन ही मैच नहीं कर रहे। गेटिंग द थिंग? टाइप 0 होता तो फेस हैज टू स्टार्ट विद 0 डिग्री यार, एंड अगर टाइप 1 होता फेस हैज टू स्टार्ट विद -90 डिग्री, यहां तो फेस -270 डिग्री से स्टार्ट हो रहा है। ऑप्शन में तो है नहीं कोई टाइप 3। इफ द फेस इज स्टार्टिंग along -270 degree axis, if the polar plot is starting with a face of -270 or along -270, then it has to be a type 3 system। टाइप ऑप्शन में है नहीं, अब तो पूरा स्टक हो गए। सर हाउ टू डील विद दिस? पे अटेंशन। अगर मिनिमम फेस होके टाइप 0 है ना, तो वही तो कह रहा हूं, आप इसको कब यूज करोगे? एमपीएस में। अगर ये एनएमपीएस है ना, नॉन मिनिमम फेस सिस्टम है, तो फिर आपके समझ के सोच के बाहर है, इसको तो फिर क्वेश्चन से ही समझना होगा। तो मिनिमम फेस है, टाइप 0 है, तो फेस विल स्टार्ट विद 0 डिग्री। अगर नॉन मिनिमम फेस है देन ये ±180 डिग्री के अलॉन्ग स्टार्ट होगा। सो लुक एट द बोर्ड। टाइप 0 मिनिमम फेस विल स्टार्ट अलॉन्ग दिस एक्सिस, नॉन मिनिमम फेस फ्लिप कर जाएगा, विल स्टार्ट अलॉन्ग दिस एक्सिस। टाइप 1 मिनिमम फेस विल स्टार्ट अलॉन्ग दिस एक्सिस, नॉन मिनिमम फेस विल स्टार्ट अलॉन्ग दैट एक्सिस। आंसर टू द क्वेश्चन इज डी। अगर ये मिनिमम फेस होके टाइप 1 होता ना, तो -90 एक्सेस के अलॉन्ग शुरू करेगा, स्टार्ट होगा। ये नॉन मिनिमम है इसलिए तो रिवर्स होके चलेगा। आई कैन गिव यू एन एग्जांपल ऑफ दिस फंक्शन। इट इज k/s into s-1। सर कोई एग्जांपल बताओ। हाँ, k/s into s-1 टाइप तो 1 है, लेकिन इसका जो फेज है ना -270 से -180 आएगा। क्वेश्चन में तो नहीं दे रखा है, अगर ये दे दे तो बहस किस बात का, वो तो सीधा जवाब दे दे, हम प्लॉट से पहचानना है, तो इसलिए ये वाला क्वेश्चन। नेक्स्ट, polar plot of a minimum phase system is given। अब कह रहा है क्वेश्चन में पोलर प्लॉट ऑफ ए मिनिमम फेज सिस्टम इज गिवन। ऑप्शंस: ओपन लूप सिस्टम अनस्टेबल, क्लोज लूप सिस्टम स्टेबल, गेन मार्जिन नेगेटिव, फेज मार्जिन पॉजिटिव। ये है ऑप्शंस। अ वेरी रेयर कॉम्बिनेशन क्वेश्चन इट इज। पे अटेंशन, ये एमएसक्यू में है। दिस इज एन एमएसक्यू। पोलर प्लॉट ऑफ ए मिनिमम फेज सिस्टम इज गिवन। वो कह दिया उसने मिनिमम फेज, इट मींस नो ओपन लूप पोल और नो ओपन लूप जीरो लाइस इन द राइट साइड ऑफ ए स्प्लिन। राइट में कुछ नहीं है, जो भी है लेफ्ट में ही है, और कोई दूसरा सोच नहीं रहा है इस सिस्टम में। अगर ये मिनिमम फेज है और इसका स्टार्टिंग फेज क्या हो रहा है -270 डिग्री, it means this system has got 3 poles at origin, 3 poles, and what is the final phase? The final phase of the system is -90 degree, है ना? Final phase -90, so its phase is varying from -270 degree to -90 degree। ये टाइप 3 है, क्योंकि फेज स्टार्टिंग विद -270, क्योंकि एमपीएस है, सो डेफिनेटली इट इज टाइप 3। Final phase -90 degree, it means P minus Z. This will indicate type, but this will indicate P minus Z. यहां पर लोग बड़ा कंफ्यूज होते हैं। Final phase will not indicate the total number of poles, it indicates the number of poles minus 0, P minus Z. तो 3 minus 1, 2, I'm sorry, 3 minus 2, 1। तो 3 पोल होनी चाहिए, 2 जीरो होनी चाहिए। 3 पोल तो है, मान लीजिए कुछ 2 जीरो भी ले लें इस सिस्टम में, तो एक रफ मॉडल ऐसे बन जाएगा। यही हो जरूरी नहीं है, मतलब मान लीजिए कि टोटली 4 पोल 2 जीरो भी हो सकते हैं, एक और फाइनाइट पोल, सॉरी 4 पोल और 3 जीरो भी हो सकते हैं, एक और जीरो भी ला सकते हैं, बट एक बेसिक मॉडल मान के चले हम। मिनिमम फेस है तो जितने भी फाइनाइट पोल जीरोस है वो लेफ्ट में ही होनी चाहिए। तो ये एक मॉडल इस सिस्टम का। सर क्या ये ओपन लूप सिस्टम अनस्टेबल? हाँ बिल्कुल अनस्टेबल, बिकॉज इट हैज गॉट 3 पोल्स एट ऑरिजिन। मल्टीपल ओपन लूप पोल्स एट ऑरिजिन, ओपन लूप सिस्टम इज अनस्टेबल, व्हाट अबाउट क्लोज लूप, वो तो कुछ भी हो सकता है, वी डोंट नो। ठीक है, तो अगर ऑरिजिन के पास मल्टीपल होने से अनस्टेबल, ओपन लूप पोल्स मल्टीपल है, ओपन लूप अनस्टेबल, क्लोज लूप पोल्स मल्टीपल है, क्लोज लूप इज अनस्टेबल। बट सिंस ओपन लूप पोल्स आर मल्टीपल, यू डोंट इमीडिएटली से दैट द क्लोज लूप सिस्टम इज आल्सो अनस्टेबल। उसके लिए तो पोलर प्लॉट या कोई और तरीके देखने हैं। तो इट इज मेंशन दैट इंटरसेप्ट इज -10, सो -1 इज समवेयर हियर, इट इज कमिंग टू द लेफ्ट साइड ऑफ द पोलर प्लॉट, किसी भी डायरेक्शन से देख लो, कमिंग टू द लेफ्ट साइड। यार ये क्लोज लूप सिस्टम स्टेबल होकर निकल आया, हो सकता है, नथिंग रॉन्ग। If open loop system is unstable, the closed loop can be stable because due to 3 poles at origin, open loop is unstable, but these 2 zeros in the closed loop is stabilizing the system with a negative feedback. Well and good. What about gain margin? Sir, आपने कहा था gain margin happens to be the reciprocal of the intercept made by the polar plot on -180 degree axis. Polar plot का जो intercept है ना -180 degree axis पे, तो ये है less than 1 dB में नेगेटिव होगा, वो भी ऑप्शन दे रखा है, वो भी चूज कर लिया। लेट मी एक्सप्लेन। तो गेन मार्जिन नेगेटिव, हाँ बिल्कुल सही है, क्योंकि जब इंटरसेप्ट 10 है ना तो 1/10 ये -20 dB, -20 dB आ रहा है इसका गेन मार्जिन। लेकिन सर क्लोज लूप सिस्टम स्टेबल कैसे हुआ? दैट्स द शॉक, पे अटेंशन। फेज मार्जिन पॉजिटिव, फेज मार्जिन कहां पता करते हैं पता है यार? ओमेगा जीसी, ये ओमेगा पीसी है जहां गेन मार्जिन पता करेंगे, और फेज मार्जिन ओमेगा जीसी के पास। ओमेगा जीसी कहां होगा? जहां पोलर प्लॉट और यूनिट सर्कल इंटरसेक्ट करेंगे विद ईच अदर। जब ये -1 है, पोलर प्लॉट के लेफ्ट में जो आया था, यहां ओमेगा जीसी होगा, यहां फेजर ड्रॉ करेंगे, तो ये जो फेज है ना ये पॉजिटिव, दिस इज फेज मार्जिन, पॉजिटिव फेज मार्जिन, दिस इज फेज मार्जिन। हाउ मच आई डोंट नो, बट आई नो इट इज पॉजिटिव। वैल्यू कहां बात कर रहा है? तो ये मान लीजिए कुछ -150 है, तो 180 - 150 पॉजिटिव, फेज मार्जिन इज पॉजिटिव। टोटली शॉकिंग क्वेश्चन, टोटली शॉकिंग, हजम ही नहीं होगा ये सवाल तो। ओपन लूप अनस्टेबल, क्लोज लूप स्टेबल, गेन मार्जिन नेगेटिव, फेस मार्जिन पॉजिटिव। सर गेन मार्जिन फेस मार्जिन दोनों को तो सेम साइन होनी चाहिए, और उसके हिसाब से अगर ये पॉजिटिव है तो ये तो स्टेबल, चलो मान लिए सर, जब ये पॉजिटिव है ये भी पॉजिटिव होना चाहिए, या फिर चलो सर ये नेगेटिव है, मान लिया अगर ये नेगेटिव है तो ये भी नेगेटिव होना चाहिए और सिस्टम अनस्टेबल होना चाहिए, लेकिन आप तो क्लोज लूप सिस्टम को स्टेबल कह रहे हो। इतना कंट्राडिक्टिंग होगा ऑप्शन में, और अनफॉर्चुनेटली इसका आंसर है ABCDMSQ, चारों सही है। I told you that if gain margin is negative, phase margin should be negative. If gain margin is positive, phase margin should be positive. If gain margin 0, phase margin should be 0. And I told you that it is a compulsion for minimum phase systems. It is not compulsion for non-minimum phase system. हमने बहुत सारे ऐसे questions देखा है जिसमें non-minimum phase system में कि GM positive है तो PM negative होगा, हो सकता है. So that's why we don't apply this concept of gain margin, phase margin to the non-minimum phase system. तो हमने नॉन मिनिमम फेज सिस्टम को इस कॉन्सेप्ट से दूर रखा है, सिर्फ मिनिमम फेज सिस्टम के लिए ही एंटरटेन किया है। सर सिस्टम मिनिमम फेज ही है लेकिन फिर भी उल्टा पुल्टा हो रहा है। सर होगा जब देखो गेन मार्जिन का एक फॉर्मूला है, गेन मार्जिन इज के क्रिटिकल अपॉन के गिवन, वी नो दैट, या फिर के टेकन। दो तरह के सिस्टम्स होते हैं। देखिए गेन मार्जिन इज डिफाइंड ओनली फॉर कंडीशनली स्टेबल सिस्टम, यही चक्कर है गेन मार्जिन से। आई जस्ट वांट यू टू अंडरस्टैंड। देखो जब गेन मार्जिन और फेज मार्जिन में कॉन्फ्लिक्ट अराइज करे ना, तो यू बिलीव इन फेज मार्जिन, पर्टिकुलरली इन मिनिमम फेज सिस्टम, दैट्स व्हाई फेज मार्जिन इज प्रिफर्ड देन गेन मार्जिन। नॉन मिनिमम फेज सिस्टम के लिए तो हम किसी को प्रेफर नहीं करेंगे यार, जितना गेन मार्जिन मिसलीड करेगा ना, इतना फेज मार्जिन भी मिसलीड कर सकता है नॉन मिनिमम फेज सिस्टम में। सो वी डोंट बिलीव इन नॉन मिनिमम फेज सिस्टम GM-PM, वी अप्लाई टू ओनली फॉर मिनिमम फेज सिस्टम। फिर भी मिनिमम फेज सिस्टम में GM और PM के बीच में जब कोई टकराव आए तो फिर बिलीव इन फेज मार्जिन नॉट द गेन मार्जिन, क्योंकि इसके हिसाब से तो ये ऑप्शन गलत होना चाहिए। ये सही है तो वो इसके जस्टिफिकेशन में हो रहा है। तो यहाँ गेन मार्जिन तो नेगेटिव है लेकिन इसके थ्रू स्टेबिलिटी समझने की कोशिश ना करें। तो व्हाई इट हैपेंस लाइक दिस, गेन मार्जिन इज डिफाइंड ओनली फॉर कंडीशनली स्टेबल सिस्टम, फॉर एब्सोल्युटली स्टेबल इट इज नॉट डिफाइंड, कंडीशनली स्टेबल होना चाहिए। If the condition of stability K critical is upper limit, then gain margin will be positive. If it is lower limit, then gain margin will be negative. We had a question earlier. I need some place to write. देखिए एक ओपन लूप ट्रांसफर फंक्शन था K S+8 S+10 upon S+1 S+2. We solved this question. हमने इसको सॉल्व किया था। इस क्वेश्चन को भी समझा देता हूं। अभी जो हमने एक मॉडल है इसका भी बात कर लेंगे। तो ये दिस सिस्टम इज फाउंड टू बी स्टेबल फॉर 0 लेस दैन के लेस दैन 1/3 और 1 लेस दैन के लेस दैन इंफिनिटी, है ना. व्हाट इज 1/3? के क्रिटिकल, मार्जिनली स्टेबल, राइट. व्हाट इज 1? भाई ये भी के क्रिटिकल. गेन मार्जिन is k critical by k given. If I take any value of k in this interval, this k critical is greater than that of k given. So here gain margin will definitely be positive. For sure, greater than 1. dB में positive. In this range your system is stable. This is k critical, but any value of k in this interval is greater than 1. So that given value of k is greater than the critical value. यहाँ तो gain margin negative आएगा, but still the system is stable. Let us say k is equal to 2. K critical is 1. 1/2. भाई less than 1. dB में तो negative dB, minus 6 dB आ गया वो. But for given value of k is equals to 2, your system is stable, but the gain margin is negative. Here, 1/3, how much? 0.3. If I take k to be 0.1, then gain margin is 0.3 critical by given 0.1 greater than 1. ये तो positive आ जाएगा dB में. So what you need to understand, if the critical gain happens to be upper limit of the conditional stability, then the gain margin will be positive for that stable system. But if the critical gain happens to be the lower limit of the conditional stability, then the gain margin will be negative of the same stable system. System तो अभी भी stable है, उसके बावजूद gain margin negative आएगा. तो गेन मार्जिन के साइन से कभी मिसलीड भी हो सकते हैं व्हेन द क्रिटिकल गेन इज द लोअर लिमिट ऑफ द कंडीशनल स्टेबिलिटी, इसलिए यहां हो रहे हैं. तो कहना तो सही है इसका गेन मार्जिन नेगेटिव, उसके बावजूद आपका सिस्टम स्टेबल, क्योंकि इसका जो क्रिटिकल गेन है ना वो लोअर लिमिट ऑफ द कंडीशनल स्टेबिलिटी है. लेट मी गिव एन एग्जांपल फॉर दिस क्वेश्चन. वी हैव सॉल्व्ड, वी इन द सेंस, आई मीन इफ यू happen to be the classroom student of Made Easy, online or offline, I'm talking about this. We have solved this question जो इसमें सूट करेगा. इसका जो stability condition है ना 1/2 less than k less than infinity. So k critical is the lower limit of the conditional stability. So any value of k that you choose in this interval where the system is stable will definitely be more than 1/2. तो जब आप k critical by k given करोगे तो 1/2 by a value greater than 1/2 नेगेटिव ही आना है. लेकिन ये नेगेटिवनेस ऑफ द गेन मार्जिन, इसको सिस्टम को अनस्टेबल के लिए इस्तेमाल नहीं करोगे. भाई सिस्टम तो आपका स्टेबल है, हाँ गेन मार्जिन नेगेटिव है. तो ए वेरी रेयर हैपनिंग क्वेश्चन वेयर गेन मार्जिन इज नेगेटिव, फेस मार्जिन इज पॉजिटिव, बट स्टिल द क्लोज लूप सिस्टम इज स्टेबल, दो द ओपन लूप सिस्टम इज अनस्टेबल इन स्पाइट ऑफ द सिस्टम बीइंग मिनिमम फेस सिस्टम. इतने सारे अजूबे मिला हुआ क्वेश्चन है ये अक्सर नहीं होगा, अब हो रहे हैं. तो देख लो एक ऐसा भी क्वेश्चन. And you know sometimes root locus will move from the right side of his plane to the left side of his plane. वहां भी होगा ऐसे ही. मान लीजिए रूट लोकस ऐसे बिहेव कर रहे हैं. दिस इज के क्रिटिकल, सिस्टम इज स्टेबल ओनली अप टू दिस, सो समवेयर हियर के गिवन. तो के क्रिटिकल बाय के गिवन पॉजिटिव ग्रेटर दैन 1. पॉजिटिव मतलब डीबी में पॉजिटिव, अदरवाइज ग्रेटर दैन 1. सपोज जब कोई रूट लोकस ऐसे बिहेव कर रहा है, ये है के क्रिटिकल. तो फॉर एनी गिवन वैल्यू ऑफ के वेयर योर सिस्टम इज स्टेबल, के क्रिटिकल बाय के गिवन करेंगे तो ये वैल्यू तो लेस देन 1 आएगा, तो गेन मार्जिन तो नेगेटिव होगा. सिंपल लॉजिक. Consider open loop transfer function of a system to be k upon s plus a, s plus b. One question of gain margin. For k is equal to 2, gain margin is 32 dB. Find the value of k when the gain margin is 25 dB. इसको सॉल्व करने के दो तरीके. एक तरीका ये है कि गेन मार्जिन जो 32 dB है ना, dB से कन्वर्ट करोगे तो 40. K critical upon K given is 40. So K critical is K given 2 ना 80. K critical यहां से निकलेगा. 25 dB मतलब 18 if you convert it from dB. So gain margin K critical upon K, नहीं तरीका तो एक ही है ना, ये मतलब दूसरा तरीका यहाँ समझाऊंगा. तो K critical upon K given ही तो पता करना है, is 18 gain margin है ना. So this is 80. So what is K that you have to find is 80 by 18. K given is 2. 80 by 18 कितना होगा? 4.4. That is the answer to the question. Another way is gain margin is proportional to magnitude, inversely proportional to magnitude. Magnitude is directly proportional to K. तो गेन मार्जिन अगर 40 होगा ना तो मैग्नीट्यूड 1/40. गेन मार्जिन 18 हुआ तो मैग्नीट्यूड 1/18. तो K और मैग्नीट्यूड इनके बीच में तो डायरेक्ट रिलेशन, गेन मार्जिन और मैग्नीट्यूड इनके बीच में तो इनवर्स रिलेशन. जब K 2 होगा तो मैग्नीट्यूड 1/40, या फिर यूं बात करूं मैं, मैग्नीट्यूड और K. मैग्नीट्यूड 1/40 तो K 2, तो मैग्नीट्यूड 1/18 तो K कितना, लीनियर रिलेशन है ना, 1/18 by 1/40 into 2. तो फिर ये वहीं पे आएगा मामला. तो 80 by 18 द सेम वैल्यू 4.44. सर आपने फंक्शन का तो इस्तेमाल ही नहीं किया, मैं क्यों करूं जब ऐसे हो पा रहे. तो why do you unnecessarily go for it? Sir, gain margin 32 dB. Gain margin is calculated at phase crossover frequency. Phase crossover frequency is the frequency where phase is -180. आप फंक्शन के फेज को -180 के इक्वल करके आप ओमेगा पी से निकाल ही नहीं सकते हो क्योंकि ए और बी तो अननोन है. हाउ डू यू सॉल्व इट? दैट वे. So unnecessary. I mean, think this way. Questions of this kind are also, I mean, equally happening. I think, I mean, enough with the polar plot. Let's have a discussion about few Nyquist plot questions. Nyquist plot, which is the extension of the polar plot to find, mainly to find the number of roots causing instability. Consider a system with forward path function g and feedback function h. इसका नाइक्विस्ट प्लॉट दे रखा है. This is the Nyquist plot. It is mentioned that g of s is stable. It is mentioned. Options. G of s is all pass. G of s is MPS. G of s is NMPS. G of s is strictly proper. ये है आपके ऑप्शंस जो इस क्वेश्चन के रिलेटेड. Okay. See, I mean, I can see your messages. I can see that you are replying, you're providing your answers, but I don't have enough time to address to them right from the beginning. I'm focusing more on what I have to teach rather than trying to take your doubts. और कोई से ये तो करते ही रहेंगे. तो क्लास में भी आपके डाउट्स लेते हैं, क्लास के बाद भी लेते हैं, टेलीग्राम में तो डेली ले ही रहा हूँ ईसी और इलेक्ट्रिकल की कंट्रोल सिस्टम के डाउट्स. आई मीन, और आपके मेडीजी ऐप में भी है. वेर एवर, for everyone it is a telegram group. For Medisi app, everywhere of course you are getting the doubts. So let's not waste this valuable time to answer to the queries or whatever. आप जवाब दे रहे हैं तो अच्छी बात है, but I'm really not paying much attention to that. I'm paying more attention to what I just want to convey in this little amount of the time. I'm trying to cover almost all the topics with आई मीन फ्यू क्वेश्चंस. चलिए ठीक है, इसका बात करेंगे हम. तो g of s is stable. It means there is no open loop hole in the right side of s plane. P is equal to 0. कोई भी सिस्टम स्टेबल का मतलब है P is equal to 0. सर अगर P is equal to यानी कोई भी पोल राइट में नहीं है तो ये NMPS कैसे होगा? भाई पोल 0 राइट में नहीं है तो 0 तो राइट में हो सकता है ना, तो NMPS हो सकता है बराबर. सर क्या हाउ टू एलिमिनेट द ऑप्शंस? मैंने एक तरीका ये है, देखो अगर ये स्ट्रिक्टली प्रॉपर होता ना, यानी हैविंग मोर नंबर ऑफ पोल्स ग्रेटर देन नंबर ऑफ जीरोस, फाइनल मैग्नीट्यूड हमेशा 0 होगा. If it is strictly proper, for omega is equals to 0, magnitude will be 0. यहाँ तो ओमेगा 0 पे और ओमेगा इन्फाइनाइट पे दोनों पे मैग्नीट्यूड फाइनाइट है, स्ट्रिक्टली प्रॉपर नहीं है ये. ओके, तो ये प्रॉपर है, स्ट्रिक्टली प्रॉपर तो है नहीं, प्रॉपर है. प्रॉपर मतलब इक्वल नंबर ऑफ पोल्स ऑन 0. प्रॉपर होके मिनिमम फेस होता ना, प्रॉपर होके फेस मिनिमम होता तो फेस 0 से 0 ही जा सकता है और कहीं नहीं जा सकता. प्रॉपर मतलब इक्वल नंबर ऑफ पोल 0. स्ट्रिक्टली प्रॉपर नहीं है, प्रॉपर है. इम्प्रॉपर भी नहीं, क्योंकि इम्प्रॉपर होता तो फाइनल मैग्नीट्यूड इंफिनिटी, स्ट्रिक्टली प्रॉपर होगा तो फाइनल मैग्नीट्यूड 0. अगर प्रॉपर है तो ही फाइनल मैग्नीट्यूड फाइनाइट होगा. प्रॉपर होके मिनिमम फेस होता तो फाइनल फेस 0 डिग्री और इनिशियल फेस 0 डिग्री होना चाहिए. वो बिहेवियर भी नहीं देखा गया. ये मिनिमम फेस भी नहीं है, ये नॉन मिनिमम फेस सिस्टम है. सर क्या ये ऑल पास है? अगर ऑल पास होता तो इंटरसेप्ट्स दोनों एक्सेस पे इक्वल बनाता. अनइक्वल इंटरसेप्ट्स ऑल पास के नहीं हो सकते. ये तो NMPS है. ये है मेरा एक तरीके का एक्सप्लेनेशन. दूसरा एक्सप्लेनेशन, द अदर वे ऑफ एक्सप्लेनिंग द थिंग्स इज ये Nyquist प्लॉट है. Remember, we obtain the Nyquist plot according to the Nyquist contour. Let me state the Nyquist stability criteria 1 so that you can recall everything. The Nyquist plot in GH plane, which is obtained corresponding to the Nyquist contour in S plane, which does not pass through any poles of the function g of s, must encircle the reference point -1, 0 as many times as the number of open loop poles lying in the right side of S plane. If we consider the Nyquist contour in clockwise direction, which is the default case, then the encirclements of the Nyquist plot in GH plane with respect to -1 in anti-clockwise direction will be taken as positive. In clockwise direction, we take it to be negative. If I consider the Nyquist contour in anti-clockwise direction, which should be mentioned in the questions specifically, then the encirclements of the Nyquist plot with respect to -1 in GH plane in clockwise direction will be positive and in anti-clockwise direction will be negative. As simple as that. If nothing mentioned about the Nyquist contour corresponding to which we get the Nyquist plot, we consider the Nyquist contour to be in clockwise direction by default. So if Nyquist contour is in clockwise direction, then encirclements of the Nyquist plot with respect to -1 will be in clockwise, in negative, anti-clockwise, positive. यहाँ तो वो बहस भी नहीं है क्योंकि Nyquist plot -1 को तो encircle कर ही नहीं रहा है. So what? Pay attention. N is equal to P minus Z. और आपको क्लोज लूप को कोई बात भी नहीं कर रहा है क्वेश्चन में. N is equal to P minus Z. Sir, what is Z? What is P? Depends on आप N किसके रेस्पेक्ट में निकाल रहे हैं. बड़ा इंपॉर्टेंट और सिंपल कॉन्सेप्ट है. प्लीज पे अटेंशन. इफ यू आर कंसिडरिंग द नंबर ऑफ एनसर्कलमेंट्स ऑन द Nyquist प्लॉट विद रेस्पेक्ट टू origin, then I mean where function is open loop, you have open loop function. Of course, we take open loop function, we obtain the Nyquist plot for the open loop function. The Nyquist plot which is obtained for open loop transfer function, if you see the encirclements with respect to origin, then this Z will be open loop zeros, this P will be open loop poles. Whereas, if you consider this N with respect to -1, 0, this P will be open loop poles, but this will be closed loop poles. That's a simple logic. That's all. So if you consider encirclements with respect to -1, Z is closed loop pole, P is open loop pole. If you consider encirclements with respect to origin, then P is open loop pole in both the cases, but Z will be open loop zeros. तो इसके बेस में recent GATE question भी है, which I'm going to discuss immediately after this. What's the point of discussion, sir? Closed loop system तो वैसे ही stable है, वो तो साफ दिखाई दे रहा है आपको. क्यों? Open loop system stable. P is equal to 0. Nyquist plot is not encircling -1, 0. N is equal to 0. N is equals to P. Z is equal to 0. तो -1, 0 के रेस्पेक्ट में अगर N 0 है और P 0 है, Z जो क्लोज लूप पोल्स है ना वो भी 0 है, इट इज नॉट एट ऑल काजिंग एनी अनस्टेबिलिटी. क्लोज लूप सिस्टम इज स्टेबल और उस ऑप्शन में है भी नहीं. फॉरगेट अबाउट इट. ओपन लूप के बारे में, एंड अनदर वे ऑफ आंसरिंग टू द क्वेश्चन इज व्हाट आई एम एक्सप्लेनिंग. प्लीज पे अटेंशन. If Nyquist contour encircles a Nyquist contour by default in clockwise direction, if it encircles zeros, then the Nyquist plot will encircle in clockwise direction. If it encircles poles, then the Nyquist plot will encircle in anti-clockwise direction. I see that this Nyquist plot is encircling the origin once in clockwise direction, which means that the Nyquist contour is encircling a zero of the system in clockwise direction. जीरो को अगर नाइक्विस्ट कॉन्टूर क्लॉकवाइज डायरेक्शन में एनसर्कल करेगा तो नाइक्विस्ट प्लॉट भी रेफरेंस पॉइंट को क्लॉकवाइज डायरेक्शन में ही एनसर्कल करेगा. अगर ओपन लूप जीरो राइट साइड में है तो ऑरिजिन को एनसर्कल करेगा. अगर क्यू ऑफ एस का जीरो यानी क्लोज लूप पोल राइट साइड में है तो -1, 0 को एनसर्कल करेगा, जैसे रिटर्न यहां पर. So, since origin is being encircled once by this Nyquist plot in clockwise direction, which means that the Nyquist contour of this system is encircling 1, 0 in clockwise direction. Nyquist contour can encircle only those poles and zeros of any function which are in the right side of S-plane. So, it's a clear indication that 1, 0 of this system is in the right side, though there is no pole of the system is in the right side, and that means that the system is non-minimum phase. बहस खत्म. Now let me take that controversial question of the Nyquist, which came in the previous GATE examination. That is because, controversial because there was a mistake in the question formation itself. Let me first, explain that question. Many students ask this question. I try to explain in text, but इतना बात समझ में नहीं आती. यहाँ पर orally समझाएं तो ज़्यादा बेहतर है. तो it's like an encirclement here, another encirclement here, third one here, fourth one here. This is clockwise direction. ये -1, ये 0, ये -2, ऐसे कुछ दे रखा है. So in this question, which is GATE 21 question, Nyquist plot of a system which has 1, 0 in the right side of S-plane is given. Nyquist plot is obtained for open loop transfer function. Nyquist plot of a system having 1, 0 in the right side of S-plane is given. यानी 1 open loop 0 is in the right side. ये जो 0 है ना, open loop 0. Nyquist plot of a system having 1, 0 in the right side of S-plane is given. एक open loop 0 right में है, ये कह दिया उसने. Question is, find how many number of closed loop poles are in the right side of S-plane. Fine. हाँ. Let me first apply n is equal to p minus z with respect to origin. क्योंकि if I have to find how many number of closed loop poles are in the right side of S-plane, we know that it is p minus n. p के बारे में तो कोई information नहीं है. तो फर्स्ट मैं क्या करूंगा, origin के रेस्पेक्ट में अप्लाई करूंगा n is equals to p minus z वाले फॉर्मूला को. तो how many times it is encircled? Once in clockwise, once again in clockwise. n is how much? n is -2. 2 times clockwise में. What is p? Unknown. What is z? 1. So what you get p to be -2 plus 1 -1. यहाँ stuck हो जाएंगे हर कोई. We got stuck here. Why, sir? How can p be negative? What is p? Number of open loop holes in the right side. Number of open loop holes or number of closed loop holes, number of open loop zeros. ये कभी नेगेटिव नहीं हो सकते. नेगेटिव अगर कोई हो सकता है तो n ही हो सकता है. तो p -1 absurd. यहां पर बात ही खत्म हो गई. अब आगे बहस ही ना करें. Why this happened? Because most of the people who know the concept, they get stuck here. The reason is this Nyquist plot is obtained for anti-clockwise direction of the Nyquist contour, and it is not mentioned anywhere in the question. This question was challenged and marks were given to everyone. तो इस Nyquist प्लॉट को एंटी क्लॉकवाइज डायरेक्शन ऑफ द Nyquist कंटूर के लिए बनाया है उसने, और उसने बताना भूल गया क्वेश्चन में. तो फिर मैं तो बाय डिफॉल्ट इसी माइंडसेट से चलूंगा कि दिस Nyquist प्लॉट इज ऑब्टेन्ड फॉर द क्लॉकवाइज डायरेक्शन ऑफ द Nyquist कंटूर. देन फॉर मी एनसर्कलमेंट्स विद रिस्पेक्ट टू एनी पॉइंट ऑफ द Nyquist प्लॉट इन क्लॉकवाइज डायरेक्शन विल बी नेगेटिव, इन एंटी क्लॉकवाइज डायरेक्शन विल बी पॉजिटिव. उसी इंटेंशन से चला तो फिर बात तो खत्म हो गई. तो दिस वे इट इज रॉन्ग. So what has to be mentioned actually, ये word add करना चाहिए था, Nyquist plot for anti-clockwise direction of Nyquist contour is given. ये कहना चाहिए था उसको, क्योंकि एग्जाम में मैं ये ना हो तो वो कर लूं, इतना कूल माइंड कहां से रखूं भाई, नहीं होगा ना. तो देन सर अब क्या फर्क पड़ेगा, n is equals to p minus z, ये तो एक ही चीज है. लेकिन अब n क्या करेंगे, origin is encircled 2 times in clockwise direction. For anti-clockwise direction of the Nyquist contour, encirclements of the Nyquist plot in anti-clockwise direction will be negative, in clockwise direction will be positive. अब n को 2 लेंगे, p नहीं पता, Z1 उसने खुद ही कहा है P इज इक्वल्स टू 3, 3 ओपन लूप होल राइट साइड ऑफ एस प्लेन में है। ओके, नाउ वी अप्लाई दिस n इज इक्वल्स टू P माइनस Z विद रेस्पेक्ट टू -1,0। तो -1,0 यहां है, -1, सर क्यों कर रहे हैं? अब क्लोज लूप पोल की बात करना है, ओपन लूप पोल है ये, अब मेरे को क्लोज लूप पोल पता करना है, वही तो सवाल किया ना। ये तो 3 है, क्योंकि उस केस में भी इस केस में भी P तो सेम है, तो ये Z यही तो मालूम करना है ना, यही तो पता करना है। तो व्हाट इज n? और यहां पर वंस इन एंटी क्लॉकवाइज डायरेक्शन -1, वंस इन क्लॉकवाइज डायरेक्शन +1, n is equals to 0, Z is equals to 3. 3 closed loop poles are in the right side is the answer to the question. Got that point? Now this question must be understood by everyone. I think that's enough with the Nyquist plot. इससे ज़्यादा कोई कन्फ्यूजन नहीं होगा आपको, तो अब क्लैरिटी मिल गई होंगी। सो प्लीज बी केयरफुल। Nyquist कंटूर के डायरेक्शन के बेस पे n को जज करना है आपको, डोंट डू इट ब्लाइंडली। तो आप ऑरिजिन को रेफरेंस बना रहे हैं, देन यू आर टॉकिंग अबाउट ओपन लूप फंक्शन। अगर आप -1 को 0 बना रहे हैं तो यू आर टॉकिंग अबाउट क्लोज लूप फंक्शन। नेक्स्ट, open loop transfer function of a system is 1 upon s plus 0.1 s plus 10. This question, again, many students are getting bothered, getting confused. Question क्या था? Find error in board phase plot for omega is equal to 0.1. Find error in board phase plot for omega is equal to 0.1. ये है सवाल। Let me remind you, error in the magnitude plot, we know very well. हम वैसे generally error in the phase plot बात नहीं करते हैं क्योंकि ज़्यादा approximations होते हैं phase plot में। We know the error in the magnitude plot. At corner frequency, error will be -3 dB. Corner frequency by 2 omega c. By 10 into 10 -3 dB -2 dB -1 dB 0 dB। कॉर्नर फ्रीक्वेंसी के पास एरर -3 dB, 1 octave below and above -1 dB, 1 decade below and above 0 dB. This is the error in the magnitude plot of a simple pole. अगर मल्टीपल पोल है तो आप एरर को भी मल्टीप्लाई कर लेना, कॉम्प्लेक्स पोल्स हैं तो फिर वो एरर जीटा पे भी डिपेंड करेगा। क्वेश्चन इज टू फाइंड द एरर इन द फेस प्लॉट। सर इसका जो मैग्नीट्यूड प्लॉट जो हम ड्रॉ करते हैं ना, अगर इसको मैं टाइम कांस्टेंट फॉर्म में लेके जाऊं, इट इज 1/10s + 1 0.1s + 1। तो 0 dB मैग्नीट्यूड, 0 dB फेस एट सम फ्रीक्वेंसी, एंड देन मान लीजिए कोई 0.01 फ्रीक्वेंसी पे इसको स्टार्ट करें, एंड एट कॉर्नर फ्रीक्वेंसी 0.1 स्लोप चेंजेस टू -20, एंड एट कॉर्नर फ्रीक्वेंसी 10 द स्लोप चेंजेस टू -40 dB पर डिकेड। ये है इसका मैग्नीट्यूड प्लॉट। सर आपने इसका सिंक्रोनस में एक फेस प्लॉट बनाया, 0 स्लोप मतलब 0 फेस, फिर -90 फेस -180 फेस, 0 डिग्री -90 डिग्री -180 डिग्री फेस। दिस इज हाउ वी डिस्कस थिंग्स, राइट? क्लास में ऐसे ही बात की। दिस इज स्लोप ऑफ द मैग्नीट्यूड प्लॉट। These are not face of the face slope of the face plot, they are the values of the faces. Face plot के दो तरीके हैं, एक ये है, this is one way of obtaining the face plot. In this we show the corner frequencies and the amount of the change in the phase at the corner frequency. Phase का value है ये, ये मैग्नीट्यूड का वैल्यू नहीं, स्लोप है. दिस इज नॉट वैल्यू ऑफ द मैग्नीट्यूड, दिस इज द स्लोप ऑफ द मैग्नीट्यूड प्लॉट. दिस इज नॉट स्लोप ऑफ द फेस, दिस इज द वैल्यू ऑफ द फेस. यहां फेस के वैल्यूज हैं, यहां पर मैग्नीट्यूड प्लॉट में स्लोप है. दो अलग चीजें हैं. वेदर यू गिव दिस टू मी और गिव दिस टू मी, आई कैन ऑब्टेन द ट्रांसफर फंक्शन बाय रिवर्सिंग इट. ना ट्रांसफर फंक्शन तो रिवर्स करके बना सकते हैं. कॉर्नर फ्रीक्वेंसी के पास स्लोप इज चेंजिंग बाय -20, सो वन पोल अनदर पोल. कॉर्नर फ्रीक्वेंसी के पास फेस इज चेंजिंग बाय -90, वन पोल अनदर -20 अनदर पोल. This kind of the phase plot is used to obtain the transfer function from the phase plot, but you should not use this phase plot to obtain the value of the phase. आप फेस का वैल्यू सॉल्व करने के लिए इस फेस प्लॉट को इस्तेमाल ना करें. यार बहुत बेवकूफी है ये. ओमेगा इज इक्वल्स टू 0.1 पे फेस -90 क्यों होगा? नहीं होगा. ये तो मतलब वो कॉर्नर फ्रीक्वेंसी जहां पे फेस में अचानक चेंज शो करते हैं हम. अगर आप एक्चुअली बात करें एक पोल के वजह से फेस जो -90 होगा, इट विल बी एट ओमेगा इज इक्वल्स टू इंफिनिटी, right? Not right at the corner frequency. This kind of the phase plot will give us the information about the corner frequency of the transfer function, corner frequencies of the poles and zeros, and whether it is one pole or one zero. Wherever the phase changes suddenly, its corner frequency, amount of the change in the phase is -90, one pole. जैसे यहां पर वन पोल पता चलेगा, यहां भी वन पोल पता चलेगा, बट डोंट यूज दिस एज द वैल्यू ऑफ द फेज ऑफ द सिस्टम. तो फिर सर देन व्हाट? यार उसको तो इस फेस फंक्शन लिख के बना कर बढ़ गया. व्हाट इज द फेस ऑफ द फंक्शन? माइनस tan इनवर्स ऑफ ओमेगा बाई 0.1 माइनस tan इनवर्स ऑफ ओमेगा बाई 10. इसको तो सॉल्व करेंगे भाई. at omega is equal to 0.01, start some general frequency 0.01, phase 0 degree. At omega is equals to 0.1, if you solve, phase will become 45 degree. At omega is equal to 1, phase will be roughly 135 degree. Solve करना पड़ेगा आपको. At omega is equals to नहीं 135 नहीं, I'm sorry, ये 45, ये 45 9. At omega is equals to 1, हाँ 90, 135. यहाँ देखिए, यहाँ पर 0 डिग्री आएगा फेस. सर कैसे? सॉल्व करके, इसमें सब्स्टिट्यूट करके. ओमेगा इज इक्वल्स टू 0.1 -45 डिग्री आएगा, नियर अबाउट, रफली बात करो मैं. ओमेगा इज इक्वल्स टू 0.1 पे, हाँ ओमेगा इज इक्वल्स टू 1 पे ना -90 डिग्री कुछ आएगा. ओमेगा इज इक्वल्स टू 10 पे, वन सच क्वेश्चन यू हैव इन द प्रीवियस पेपर्स, -135 डिग्री आएगा. राउंड फिगर बना रहे हैं, राउंड फिगर 45 डिग्री. सो व्हाट आई कैन से दैट इट इज दिस पॉइंट्स, आई मीन एग्जैक्ट लाइन पे नहीं आ रहा है, यू कैन अंडरस्टैंड. इट्स ऑलमोस्ट लाइक अ स्ट्रेट लाइन. -90 यहाँ, -135 यहाँ. जीरो डिग्री, 0.01 पे 0 डिग्री, सॉरी 0.1 पे 45 डिग्री, 1 पे 90 डिग्री. ये पॉइंट्स हैं, आई एम सॉरी. सो प्लॉट विल बी दिस, कुछ इस तरह बन रहा है. At omega is equals to 0.1, you calculate exactly जो है 45.5 आएगा. मैं उसको 45 डिग्री राउंड ऑफ कर देता हूं, राउंडेड ऑफ टू द नियर बाय इंटीजर वैल्यू. At omega is equal to 1, ये 88 डिग्री आएगा, मैं उसको 90 डिग्री पे राउंड ऑफ कर देता हूं. At omega is equal to 10, ये 133 डिग्री कुछ आएगा, मैं उसको 135 डिग्री पे राउंड ऑफ कर देता हूं. देयर बाय आई कैन से दैट ये लगभग 45 I can define it to be 45 degree per decade. ये है ना स्लोप ऑफ द फेस प्लॉट. ये दोनों एक जैसे हैं. यहां पर स्लोप ऑफ द मैग्नीट्यूड प्लॉट लिखा है, यहां स्लोप ऑफ द फेस प्लॉट लिखा है, यहां पर स्लोप ऑफ द फेस प्लॉट नहीं है, स्लोप नहीं है, स्लोप तो यहां है. ओके, हाँ. सो व्हाट इज द क्वेश्चन सर? व्हाट इज द एरर इन द फेस प्लॉट एट फ्रीक्वेंसी 0.1? एक्चुअली सॉल्व करेंगे ना तो -45.5 डिग्री आएगा, -45.5. मैंने उसको राउंड ऑफ कर दिया है -45 डिग्री पे. एरर -0.5 डिग्री, दैट्स इट. व्हाट्स अ बिग डील? सो सिंपल. So all other questions of board plot, you know very well. There are plenty other questions that we have solved, that you might have solved. But this one question where I just wanted to stress more upon, where students are getting some confusion or facing trouble. So that's about the frequency domain. Now coming to the state model. Mostly the questions of controllers compensators will be mostly theoretical and some simple numerics which you might have seen in test series and various questions. टेस्ट सीरीज में हो या फिर वर्कबुक में हो या नोट्स में, कहीं भी प्रैक्टिस में देखा होगा, उससे ज़्यादा कुछ तो है नहीं. Coming to the state model analysis, the state model has got many advantages over that of transfer function model. So the questions will be mainly based on those which are exclusive about state model. जो हम ट्रांसफर फंक्शन से भी कर सकते हैं ना, उसको फिर स्टेट मॉडल में करने में कोई मतलब ही नहीं है. So mostly the questions will be on finding the zero input response, on checking on controllability and observability. And what is that, forming the state model, obtaining the state diagram. तो ये जो चीज़ें हैं ना, इस पे ज़्यादा फोकस होता है और इन्हीं का हम कुछ डिस्कशंस करेंगे फॉर सम टाइम. सो लेट्स हैव a few questions based on the state model and its discussions. Particularly, let me address to the questions of, say, finding the response. हाँ, एक सवाल है, देखिए. If x of 0, if x of 0 is 1 minus 1, then x of t is e to the power minus t minus e to the power minus t. If x of 0 is 3, 5, then x of t is e to the power minus t minus e to the power minus 2t minus e to the power minus t plus 2 e to the power minus 2t. If x of 0 is 3, 5, then find what is x of t. This question. Just think over it. See how you approach. Yeah, you might have tried. See, one way, वो तो बड़ा लेंदी हो जाएगा. One way to answer to this question is picking eigenvalues. एक होगा -1 और दूसरा होगा -2. कोएफिशिएंट ऑफ एक्सपोनेंट. एक्सपोनेंट में जो t का जो कोएफिशिएंट होता है ना, वो आइगन वैल्यू. सो कैरेक्टरिस्टिक इक्वेशन ऑफ द सिस्टम इज s² + 3s + 2 = 0. यहां से A मैट्रिक्स लिख सकते हैं 0, 1, -2, -3. What is x of t formula? Phi of t, x of 0. x of 0 तो दे रखा है. Phi of t is inverse Laplace transform of si minus a inverse. A you got it. So find out phi of t. Use that, you will get x of t. Again, time consuming. You know what is much more shortcut? इसको x1 कहना, इसको x2 कहना. Then what will be this x of t, you know? In short, it will be 3 into x1 plus 3 plus 5 into x2. ये short, बड़ा simple. And you know the algorithm behind that. 3 into x1, 3 plus 5 into x2 will be this x, the new. इसको मैं x3 कह लेता हूँ. x3. So what is this x3 of t? You can tell your answer. 3 into x1, that is 3 e to the power minus t plus 3 plus 5, 8 into x2, 8 e to the power minus t minus 8 e to the power minus 2t. Then minus 3 e to the power minus t plus 8 into minus 8 e to the power minus t here plus 16 e to the power minus 2t. So finally, this x of t, which is x3 of t, can be written as 11 e to the power minus t minus 8 e to the power minus 2t minus 11 e to the power minus t plus 16 e to the power minus 2t. सर ये सही है? बिल्कुल सही है, हमने किया तो सही है. कैसे चेक करेंगे सर? You should know that capital X of 0 is equal to small x of 0. Simple. Capital X of 0 is equal to small x of 0. Put t is equals to 0, 1 minus 1. Put t is equals to 0, 0, 1. I'm sorry. मतलब ये response में, अच्छा ये initial condition तो same copy कर दिया ना मैंने. I'm sorry. 0 और 1. ये initial condition 0 और 1 है. Question itself is written wrongly. तो ये 1 minus 1, ये 0, 1, तो इसका x of t. तो initial condition, if you put t is equals to 0, 0 और 1 आ गया. तो फिर सर, if this is x of t, put t is equals to 0, 11 minus 8, 3, 16 minus 11, 5. सही तो है. And you know, I taught you numerous shortcuts of controllability, observability. There are numerous shortcuts of controllability and observability. Based on that, without actually using the Kalman's procedure of checking controllability, observability, you can complete the question. There are times where the shortcuts, of course, not applicable. Then, of course, you need to go by Kalman's procedure. That's inevitable, but don't use it every time. Checking controllability, observability in case of multi-input, multi-output systems is different than that of SISO. See, if a system is controllable with respect to one input, it need not be controllable with respect to other input. If a system is observable with respect to one input, output, it need not be observable with respect to other output. If you have only one input, one output, go ahead with the controllability, observability directly. If you have more than one, then you need to talk with respect to only one input at a time and only with respect to one output at a time. As an example, let the state model be minus 2, 0, 0, minus 1, x plus 1, 0, 1, 1, u. Y is equal to 0, 1, 1, 1, x plus 0, 0, 0, 0, u. Number of columns of B matrix indicates number of inputs. Number of rows of B matrix indicates order of the system. Number of rows of C matrix indicates number of outputs. Number of columns of C matrix indicates order of the system. Number of rows or number of columns of A matrix, it simply indicates order of the system. Right. Number of rows of D matrix indicates number of inputs. Number of columns of D matrix indicates number of outputs. तो ये 2 इनपुट 2 आउटपुट सिस्टम है. सर मेरे को इसकी कंट्रोलेबिलिटी चेक करनी है. To check the controllability, you have to take only one input at a time. So for input U1, you should take only this B matrix. For input U2, you should take only this B matrix. सर मेरे को observability चेक करनी है. यहाँ 2 आउटपुट हैं. With respect to output Y1, you should take only this C matrix. With respect to output Y2, you should take only this C matrix. ठीक है? A with this B, A with this B, दो अलग कैलकुलेशन. A with this C, A with this C, दो अलग कैलकुलेशन, दो अलग अलग. You need to do that. Either you can go by Kalman's test, or we have our shortcut. I can directly say that it is controllable with respect to U1, uncontrollable with respect to U2. It is unobservable with respect to Y1, it is observable with respect to Y2. We have our methods. So, what is the report, sir? Controllable. with respect to U1, not U2. Observable with respect to Y2, not Y1. That way. So remember, in case of identical states, in case of symmetrical systems, and in case of pole zero cancellation, controllability, observability fail होंगे. एक general direct shortcut. Moreover, see, ये तो state models हैं. State diagram में देखिए, if you ever see a state diagram to be this, it is 100% controllable. Direct answer. ये controllable है. Damn sure. If you ever see a state model like this, यानी from various states reaching to one node where input is applied, ये controllable होता है. If you ever see state model like this, ये 100% observable. What I'm telling you, without calculation, बगैर calculation के, ऐसा कोई system कभी दिख जाए तुमको, 100% observable. If you ever see a system like this, input is applied to both the systems, controllable. Output is obtained from both the systems, observable. Controllable. यहाँ भी गया, यहाँ भी गया. 100% controllable. यहाँ से भी आ रहे हैं, वहाँ से भी आ रहे हैं. 100% observable. Provided these are non-identical. Conditions apply. ये distinct eigenvalues. अगर repeated eigenvalues है ना, इनपुट सिर्फ फर्स्ट को दिया काफी है, आउटपुट सिर्फ सेकंड से लाया काफी है. कंट्रोलेबल, ऑब्जर्वेबल. कंट्रोलेबल, ऑब्जर्वेबल. डिस्टिंक्ट में दोनों पे अप्लाई होना है, दोनों से आउटपुट बनना है. रिपीटेड में किसी एक फर्स्ट वन पे ही इनपुट इज नॉट गोइंग टू दिस, doesn't matter, still controllable. Output is not coming from here, doesn't matter, still observable. If you ever see the state diagrams to be somewhat like this, then you can declare the controllability, observability without much calculation. Direct की बात कर रहा हूं मैं, calculation तो आप कर ही लोगे. One last thing regarding the state variable feedback. See, in case of transfer function model, suppose if I am not able to get the desired characteristics of a system, then you know what we do? We use a proper controller or a compensator so that we modify the system design and we get the desired characteristics. Yani, I want to place the poles at a particular location so that I get the desired characteristics. मान लीजिए अगर किसी सिस्टम का पोल -1 के पास है, तो इसका जो सेटलिंग टाइम है ना, वो 4 सेकेंड. लेकिन मेरे को जो सेटलिंग टाइम चाहिए वो 2 सेकेंड्स. आई वांट सेटलिंग टाइम फॉर 2% क्राइटेरिया टू बी 2 सेकेंड. अगर 2 सेकेंड्स चाहिए विद वन पोल इन द सिस्टम, तो वो पोल तो -2 के पास होना चाहिए. दिस इज द एग्जिस्टिंग पोल, बट आई वांट टू शिफ्ट दिस पोल फ्रॉम दिस लोकेशन टू दैट लोकेशन. Then I will get the desired characteristics in the system. That will be 2 seconds of settling time. ये मेरी ज़रूरत है. Only that system can be done like this. You can obtain the desired characteristics from only that system which has got the controllability to be a compulsory property. Observability is an optional thing. And how do we change the location of the pole from one to the other? In case of transfer function model, using suitable controller compensator. In case of state model, using state variable feedback design. From every state of the system, we use a controller matrix K and we bring it back to the input circuitry as a feedback called as state variable feedback. Thereby, we modify the characteristic equation and we obtain the desired characteristics. Characteristic equation from state model is mod Si minus A is equal to 0 without state variable feedback. Characteristic equation with state variable feedback is this. mod Si minus of A minus Bk is equal to 0, where A and B are the general matrices. We know them. K is the controller matrix which is going to control the location of this pole. As a matter of example, x dot is equal to minus x plus u. X dot is equal to, where has that question gone? Minus x plus u, and y is equal to x is the state model of a system. And u is, say, a control signal designed through state variable feedback, so that the pole has to be located at -2. See, अब जो pole है ना वो -1 के पास है, लेकिन मेरे को जो है pole -2 के पास ले जाना है. इससे ये रिलेटेड बात करूँ मैं, तो it's a recent GATE exam question. So using state variable feedback concept, we use a control signal, some u is equal to minus kx. By designing the value of k, I will be able to do that. So x dot is equal to minus x plus u is minus kx. So you can write x dot to be -1 minus k into x. This will be your new A matrix. Earlier A matrix was -1. Now A matrix will be -1 minus k. So what will be the characteristic equation? Mod S minus of A mod SI. ठीक है, अब जब A पता चल गया ना, now we don't have to come to this formula. ये फार्मूला तब जब आपको इंट्रोड्यूस करना, इंट्रोड्यूस कर चुके हैं. It will be this matrix. So the new A, old A is -1. What is this? This will be the new A. This is old A. This is new A. And new A is -1 minus k is equal to 0. So S plus k plus 1 is equal to 0. Therefore, k has to be 1 so that the closed loop pole can be at -2. This is state variable feedback concept. Questions are rare though, but these years, they are happening a bit frequently. So I just have, explained even that. So that's all what I've got to say, because, we really can't go for a prolonged time. So in this 3.5 hours of the time, I taught you everything about control system, not just few selected topics, because GATE is highly unpredictable. Question comes from which topic, I don't know. So right from the first topic to the last topic, I try to touch every topic with good questions, so that you understand what exactly a control system that you already know, but I'm trying to revise through all these things. So I hope that you might have benefited with all these questions. So thank you so much for your attention. Thank you for watching these things. From the depth of my heart, I wish that and I pray God that you all be successful in your respective goals, whatever it be. So be good and do good. Thank you once again for watching this. Wish you all the best. God bless you.